All living things, from bacteria to animals, are able to perceive the sensations of heat and cold directly through their senses. But because of our lack of superpowers, our abilities are very limited, because such temperature determination requires that the temperature be measured objectively, by means of instruments rather than by hand and feel. Such instruments are called thermometers and measure what is called empirical temperature. The empirical temperature scale establishes the scale of measurements and the number of divisions between them. Thus, the Celsius, Fahrenheit, and other scales now in use were introduced. But measured in Kelvin, absolute temperature is introduced by 1 point of the point on which the scale of measurement is based. Given that in nature there is a minimum limit of temperature values to absolute zero, the upper value of the temperature, however, is limited. The temperature bar is a kind of temperature maximum. The highest temperature was thought to be 10 trillion degrees Celsius. It was obtained artificially here on Earth. This absolute temperature record was obtained during an experiment at the Large Hadron Collider, the world's most powerful particle gas pedal at near the speed of light. Specialists collided beams of lead ions, which have enormous energy when heavy ions collide. Small explosions of dense fire spheres that had such monstrous temperatures began to appear. At such temperatures, the energies of the nucleus of atoms literally melts and forms a broth of their constituent quarks. As a result, in laboratory conditions, was obtained plasma with the highest temperature. And although 10 trillion degrees is an incredible, huge temperature, but it seems that this is far from the limit, as everything was limited within the framework of this experiment. Step further, we are not yet allowed by technology, so offers to make a space journey in search of the hottest source in the universe. And we start with the closest planet to us. Venus is characterized by an abnormally dense atmosphere with a pressure equivalent to 90 Earth atmospheres. Due to the monstrous greenhouse effect, the planet's surface temperature reaches 480 degrees Celsius, more than Mercury. Many known objects are also capable of approaching the Sun at a record distance. These include the asteroid Phaeton, whose center temperature can reach 750 degrees Celsius. But this object is overtaken in temperature by the satellite Io, which was one of the biggest surprises in the study of the Jupiter system by space probes, and its surface is the youngest in the solar system. It lacks impact craters. Measurements from the Galileo station have shown that volcanoes on this satellite reach temperatures of at least 3,340 degrees Celsius. The surface of the Sun has a temperature of about 5,500 degrees Celsius, but at a distance of about 10,000 kilometers from the surface of the Sun is the solar corona, which we see as a kind of halo. Its temperature reaches already 1 million degrees, but it is not all solar flares can be many tens of 1 million degrees. However, in the universe, the Sun is a perfectly ordinary star. The surface temperatures of ordinary stars range from 2,000 degrees Celsius in red dwarfs to 30,000 degrees Celsius in blue dwarfs. But do not forget that there is a special class of stars called Wolf-Raynaud stars, about which the surface temperature can exceed 50,000 degrees Celsius. The number of known stars of this type in the local group of galaxies may be only a few 1,000. Such stars are characterized by high density, the presence of ejected shells similar to planetary nebulae. They are thought to represent the last stage in the evolution of single massive stars before the supernova explosion stage. The hottest star among them is considered to be FRS 102, with a temperature of 210,000 degrees Celsius and a luminosity of half of the Sun's 1 million luminosity. The mass of this star is estimated at 20 solar masses at a radius smaller than 0.4 solar radii, but the stellar remnant has even higher temperatures. For example, the discovery of the hottest white dwarf, GHJ 0439, with a surface temperature of 240,000 Celsius, was published in 2015. We are approaching exotic remnant stars. These are neutron stars that have even higher surface temperatures. The maximum of their emission is in the X-ray and gamma rays. Thus, the brightest sources in gamma rays are a trio of neutron stars in the Crab, a prominent nebula in the Sales Nebula, and the radio-silent star of Goring. A neutron star is thought to have a surface temperature of about 100 billion Celsius at the time of its birth. That's a colossal temperature, but far from the limit. Finally, we get to black holes. We have before us, for example, a stellar mass black hole. X1 is the brightest X-ray source in the Earth's sky. And recent observations have shown that the effective temperature of the center of the nearest quasar, 30,273, is 40 trillion degrees. There is a theory that the effective temperature of dark matter in active galactic nuclei is about Kelvin, which is 10 to 1 million times the observed temperature of visible matter in these objects. The universe may be hiding even hotter objects, but we can't get to them yet. Still, we realize that the highest temperatures were at the time of the Big Bang or the beginning of inflation. Whichever you prefer. Theory says that the temperature of our universe was equal to Planck's temperature. Modern physics believes that this point is at the highest level, and it is not 10 trillion degrees at all, but much higher. In the new theory, the ultimate temperature should be 142 UN fans. Yes, as you may have noticed, this figure is much higher than the one obtained in the experiment on Earth. But why is there such a difference? The thing is that there is such a thing as a state and such a thing as the velocity distribution of particles. For the state that the previous system was in, the concept of temperature is not defined at all. Temperature is defined strictly for the same type of state as the state of equilibrium in which the so-called Maxwell velocity distribution takes place. This probability distribution, found in physics and chemistry, is the basis of kinetics and gas theory, which explains many fundamental properties of gases, including pressure and diffusion, which the experiment did not take into account. From this we can conclude that there seems to be no theoretical absolute maximum temperature, since the system can be heated to whatever temperatures it wants. Another matter is what processes will occur at high temperatures and whether we will be able to describe them. After all, at extreme temperatures we'll begin to decompose first molecules into atoms, then atoms into nuclei and electrons, then nuclei will begin to decompose into tilts, then tilts into quark-clay plasma consisting of quarks of fundamental particles that make up protons and neutrons. And what's next is unclear. After all, quarks are elementary particles, and to decay them into nothing. What will happen at high temperatures, pressures, and superspeeds, it is not clear. So the maximum limit, in this case it's related to the fact that we just don't know what happens to matter at extreme temperatures. So the question apparently remains open for now. From time to time we Earthlings witness the moon completely obscuring the sun. It's an amazing sight. But does a similar astronomical phenomenon occur on other planets, systems, and distant stars? Let's try to answer these questions. So, an eclipse is possible if a planet's satellites are large enough or close enough to obscure the sun for an observer on that planet. Also, the satellite, the sun, and the planet must be in the same plane. If the planet has no moons, forget the eclipse. For example, Mercury and Venus don't have them. Mars has 2 satellites, Phobos and Deimos, but they are too small to completely cover the sun. For a notional Martian or Mars rover. But private solar eclipses do happen. Curiously, Mars itself often obscures the sun for Phobos. And there are seasons when this happens every day. But let's turn our attention to the giant planets like Saturn, Jupiter, Uranus, and Neptune. Their satellites are large enough to outshine the distant sun. But alas, these planets are made of gas. They have no surface. Of course, a total eclipse can be observed from aboard a ship claiming the upper atmosphere of a gas giant. For example, Jupiter has 79 satellites. One of them is Animate, the largest satellite in the solar system. And they orbit in the same plane as Jupiter orbits the Sun. So all the conditions for an eclipse are in place. But what about dwarf planets like Pluto? Its companion Charon is big enough to obscure the Sun. But because it and Pluto face each other, one side of the eclipse can only be seen in one of the hemispheres of these celestial bodies. Our Moon, on the other hand, is very well placed. Apparently, it is only slightly larger than the Sun in size. During an eclipse, the Moon hides the brightest layer of the solar atmosphere, allowing us to admire the corona of the outer layer of the atmosphere. However, the Moon is slowly moving away from us and will not be able to obscure the entire Sun in the future. Someday Earthlings will observe only rings and figurative eclipses. But we should not be sad. The last total solar eclipse will occur in 600 million years. Humanity's eclipse will come much sooner. Of course, similar eclipses occur on other systems, and the sources of these eclipses may surprise you. Let's look at 2 amazing examples where eclipses last for years. In order to understand how unique the new discoveries are, it is first worth talking about the system of a bright star called Epsilon, which emerged after the publication of the second part of the catalogue of its data. Astronomers were able to significantly refine the distance to the system. It turned out that previous estimates, according to which it was about 6,400 light-years, were very exaggerated. In fact, Epsilon is located at a distance of about 1,600 light-years from the Sun. Due to this, astronomers recalculated the characteristics of the components of the system, as well as conducted a computer simulation of its evolution. According to the results obtained, immediately after the formation of Epsilon the emerged consisted of a pair of stars. The mass of the first exceeded solar in 10 times. The mass of the second was less than 5 solar masses. When the less massive component of the system began to actively pull on the matter of its companion star. Thanks to the increase in mass, it evolved much faster than its neighbor, and in 20 million years the system acquired its present form. The mass of the once larger star has decreased to just 2.2 solar masses. The luminary's large radius and brightness are attributed to the effects of active matter loss. However, an eclipse that lasts 2 years is not the limit. Let's pay attention to another interesting object, named 929821, consisting of two components of a large red giant, producing its last days, and its already extinguished older brother, whose outer shells have already been shed and had time to cool down, turning into a huge cloud of dust and gas. In the center of this cloud, judging by the fluctuations in brightness during eclipses, is the core of the former star, which in the near future should turn into a white dwarf, whose mass should be about half the solar mass. The halves of the axis revolve around each other at a relatively large distance, about 20 times farther away than the Earth is from the Sun, which is roughly the distance between Uranus and our luminary. Because of this, eclipses of this star system occur every 70 years, and they last about 3.5 years. This is the longest eclipse on record. However, because of the too great distance to the star, researchers are not yet able to get images of each of the components individually, and also to check whether there is a planet in the vicinity of this double luminary. The next eclipse of this system will begin in April 2080 and will end in September 2083. By then, future astronomers will have new telescopes that can get a picture of it. Maybe nothing will show up anymore? Yes, eclipses have provided a wealth of material for science. In ancient times, observations of eclipses helped to study celestial mechanics and understand the structure of the solar system. For example, observation of the Earth's shadow on the Moon gave the first cosmic proof of the fact that our planet is figurative. Although for some, it's proof of its flatness. Not a cloud and not a star in the Milky Way found objects unknown to science. The named objects look like gas, but behave like stars. The objects found in the center of our Milky Way galaxy. They belong to a new class. They're very compact, but they change shape as they orbit around a black hole. What are these objects? Why haven't we known anything about them before? Before we know the answers? It's worth remembering what objects in space are as such. The term astronomical object is often used along with the term body. As a rule, a celestial body is a detached, unified, and sometimes electromagnetic structure. For example, asteroids, satellites, planets, and stars' gravitationally bound structures of several bodies are represented by stellar accumulations of nebulae and galaxies. It is also curious that a comet can be described as a body relative to a nucleus composed of ice and dust, and as an object relative to a nucleus with a coma and tail. There is a distinct hierarchical structure in the universe. At cosmological distances, we can observe galaxies and dwarf galaxies of many different sizes and shapes. Galaxies are organized into groups and clusters. Further, all the clusters that lie along the large strands between practical emptinesses together form what we call the observable universe. Galaxies and dwarf galaxies have many morphological variations with shape determined by their formation and evolutionary history, as well as interactions with other galaxies. Depending morphologically on the type, a galaxy may have several structural components including spiral arms, halo, and nucleus. The core of most galaxies is believed to contain supermassive black holes, which likely give rise to active nuclear. Galaxies may have satellites in the form of dwarf galaxies and globular star clusters. The constituents of a galaxy are formed from gas and dust, collected by gravity in a hierarchical model. At this level, the most common object is stars, which tend to gather into clusters, formed in star-forming regions. The enormous variety of stars are due to the mass composition and current evolutionary stage of the stars can aggregate into a stellar system consisting of several components orbiting around each other or around a center of mass, and small bodies such as asteroids, comets, and objects in fragmentation disks are formed by the agitational processes of protoplanets. The disks surrounding newborn stars of the stellar variety are perfectly demonstrated by the so-called Russell diagram plotting the absolute luminosity of stars as a function of surface temperature. Each star follows its own evolutionary path. According to this diagram, under certain conditions, a star can become variable in the course of its evolution, changing its brightness in the visible and other. The range of the electromagnetic spectrum depending on the initial mass and the presence or absence of a stellar companion star eventually becomes a compact object, white dwarf, neutron star, or black hole. Well, now we can get back to objects that look like gas but behave like stars. What are they? That's the question astronomers asked when they first discovered two of these objects near the center of our galaxy. The first object, labeled 1, was discovered back in 2005. The second G2 was found by German colleagues in 2012, but astronomers had no idea what these findings represented. What was most disconcerting was that these ghostly substances were moving at tremendous speeds, which is, to put it mildly, not typical of a cloud of gas. And only now, just a few days ago, thanks to the ESA observatory located in Hawaii, several more objects have been discovered. Researchers also managed to capture how one of the objects too, as it approached the black hole, elongated and most of its gas broke apart. However, after passing by Sagittarius under the star, the object became compact again. Astronomers called this phenomenon a cosmic fiasco, as it was expected that G2 would be absorbed, resulting in the formation of a corrective disk. But that didn't happen. This unusual response led researchers to conclude that the objects were once double stars, forming a large star surrounded by a cloud of dust and gas. Yes, as we know, in a normal state, luminaries are locked in a common orbit and go through natural life cycles. But amazing things happen in the universe. And that's what the following example will show. Imagine a beautiful special galaxy. It has about 1,000 billion stars in it. Imagine a second one just like it. Now let's collide. Their huge star systems pass freely through each other, only bizarrely deformed by mutual attraction. It turns out the stars don't collide, they're too far apart. If you make a model of the galaxy, representing the Sun as a ball with a diameter of 1 centimeter, the nearest stars will be at a distance of about 300 kilometers. So a star is very lonely in its life. Unless fate has given it a companion star. It's time to unlock some of the mysteries of the magnet. One of the most exotic and compact objects in the universe, in the unusual properties inferior, perhaps only a black hole, is of exceptional interest to astronomers. These small, about 20 kilometers in diameter super-heavy balls are formed after the collapse of massive stars. The mass enclosed in such a volume creates a huge density at which the substance with the size of a sugar cube weighs about 1 trillion tons and will easily cross the entire planet through. Magnets have an extreme magnetic field, 1 trillion times stronger than the Earth's natural field. To date, science knows of no more than 20 of them. Behind the magnetic stars of the magnet, magnets can circulate at tremendous speeds of up to several tens of 1,000 revolutions per minute and sometimes flash in the X-ray range. The gravitational force on the magnet is balanced by the pressure. Neutron gas conditions are impossible to create in any laboratory on Earth. To have an idea of what happens to the magnet gift, consider the following example. Imagine a drop of water in weightlessness. If it does not rotate and there are no external influences, then the drop will take an exactly spherical shape due to the action of surface tension forces. Spread the drop, we get the so-called ellipse rotation at the poles, plus the note along the equator is stretched. Let now the rotation of the drop gradually slow down, then it will also gradually become a sphere. Let us now place a magnet in the place of the drop. The star owes its spherical shape to the action of gravity. Its rotation slows down at the stage of the pulsar radius, but it cannot change its shape smoothly because it has a rigid crust and mechanical stresses gradually grow in its interior. Finally, there comes a moment when the material of the crust can no longer resist them. The crust abruptly changes to a new state, and the star changes shape all at once. It's at this point that the magnet must accelerate its rotation even more. The magnet is gaining momentum. In the interior, matter is above its current state. What is it? It is such an extremely dense substance that neutrons and protons form, in fact, a giant atomic quark and a nucleus whose diameter can exceed half the diameter of the magnet. There is a version that the behavior of the magnet in this case would be peculiar. For example, the speed of sound in such a body would reach the speed of light. But even here everything is highly unusual, because the superfluid rotates in a strange way. Again, let's use an example. For this must hurtle and the explosion of the cauldron. And let's remind it of the superfluid of a magnet. Then we begin to rotate this vessel. At first, the liquid will not rotate at all. Then, when the critical rate of rotation is reached, a vortex will appear in the center of the vessel. Let's open it even more. A second one will appear, a third, and so on. But the rest of the liquid will not rotate. The properties of vortices are quantized, and their number corresponds to the rate of rotation of the vessel. The faster the rotation, the larger the vortex. The same slowing down of the rotation of the magnet is due to the forces on its cortex. The crust is rigidly bound to the bulk of the star's interior with its core, but not to the supercurrent neutrons in the inner crust or its interior, while the whole star slows down. The neutron fluid in the crust rotates as it knows how, that is, by vortices at the same rate as before. This is how the rotational velocity difference accumulates. But this cannot continue indefinitely. At some moment the system of vortices is sharply reorganized, their number changes. Now the neutron liquid of the magnet adjusts to the general rate of rotation of the star, that is, it slows down. But the system is closed. So the superfluid has transferred the excess part of its rotation, which we observe. It's hard to imagine, but in a fraction of a second, there are huge processes inside a magnet that can be affected by very small external factors. For example, if we became so powerful that we allowed ourselves to toss some substance into the magnet, we would see that very soon the mass of the object would certainly increase, and eventually the star would collapse into a black hole. But, of course, this is not to see an epic transformation, but to find out the mass at which the magnet shrinks unstoppably. That is, to find out how long a substance can withstand being bullied by fast food before it changes its form of being. That's why it's so important to find heavier and heavier neutron stars, that is, to raise the limit below which matter can still resist collapse. If eventually it is found, then we can confidently say here we see a magnet, for example, with a mass of 2.4 solar masses, and further we already see a black hole with a mass of 2.5 solar masses. And so, practically the limit for this transition between the two types of stellar remnants will be revealed. It will also tell us a great deal about how particles interact with each other at high densities, when finally their pressure is no longer enough to keep the star from collapsing. In the end, all of Magneto completes its stellar journey. All we have to do is capture the moment. At a distance of about 16,000 light-years, the star system Maxi 1621-501 has been discovered. This strange point in space was first characterized by what seemed at first to be unpredictable flashes of X-rays. It was later learned that in neutron stars, the X-rays come from thermonuclear explosions on their surface. Amazingly, the thermonuclear explosions do not occur random, but followed a pattern that repeated every 78 days, similar to an overtime clock. And that boggles the mind. Of course, we would very much like to see how these objects are formed and what happens on the surface of neutron stars, but they are so far away from us. In our country, we do not have such instruments that would allow us to see everything in detail. However, sometimes the most interesting experiments in physics can only be done in your imagination. Despite the physical limitations that do not allow us to go anywhere, cut and examine in detail any object of interest in the universe, our understanding of matter in all its manifestations and the laws that govern it has advanced quite far. We propose to take such a journey together to a neutron star. To date, we know that the neutron star is a compressed core of a massive star, very dense embers left after a supernova. Its mass is comparable to that of the Sun, but it's compressed to the size of a city. Neutron stars thus serve as the lowest reservoirs of matter in the universe. The last matter at the edge of a black hole is a newborn neutron star. It's a very hot object. The temperature of the interior exceeds 1 trillion degrees for some time. For about the first 100,000 years of its life, the neutron star cools mostly not from the surface, as any normal body does, but from the center by emitting neutrinos. At this time, the temperature of the interior is hundreds of 1 billion degrees. It is then that the terribly amazing process of heat flows deep into the star, where in a sense it disappears as the neutrino is free to leave the interior of the neutron star. To drill into such a star, we would be approaching the cutting edge of science. A couple of centimeters of normal atoms, mostly iron and silicon lying on the surface, like a bright red coating of the densest candy in the universe. Then the atoms shrink so much that they lose electrons, falling even deeper into the common sea. Protons begin to turn into neutrons so close together that they begin to overlap, giving rise to matter unknown to us. Although as of today, from a nuclear physics perspective, neutron stars may simply be made up of protons and neutrons, in other words, but clones of clones as we know them are not elementary particles. After all, they are made up of 3 quarks. Under incredibly strong pressure, quarks can form a new state of matter that is in a single quantum state. So, the closer to the surface, the lower the density. But neutron stars have one cosmic trick. Except for a thin, less than 100-meter layer near the surface, they have almost the same temperature everywhere. So the base of the outer crust gets pretty hot. If we are talking about a young and not too heavy neutron star, for example, hundreds of 1,000 years old or less, this temperature will be hundreds of 1,000,000 degrees Celsius. As a result, the outer layers can melt. This usually happens at a depth of a few tens of meters from the surface. This is where the strange ocean of water of this ocean, the so-called tilted liquid, begins. As we realize, we can't do a circumnavigation. The composition of this mass can vary from hydrogen to iron. It is in this layer of a neutron star that the temperature jumps from hundreds of 1,000,000 degrees at the bottom to 1,000,000 at the surface. The density of matter in it is tens of 1,000,000 times the density of water. It's as deep as the Sea of Azov. But the ocean covers an entire star, even if it's the size of a city. Many of the young single neutron stars that we observe due to the thermal radiation of their surface on the outside are actually liquid. That is, we see the surface of the ocean gradually transitioning into the dense atmosphere of the neutron star. In the presence of a powerful aggressive flow under the ocean, there is thermonuclear combustion of hydrogen and helium. The latter is converted, as a rule, into carbon. So basically the ocean will be made up of it. I'd like to call it a liquid diamond because the pressure there is gigantic, but that would be an exaggeration because we are waiting for a completely different world, heated to almost 1 trillion degrees Celsius ocean of carbon with a density 10 billion times greater than that of water, and it all explodes. It's called thermonuclear combustion. The flash lasts about an hour, and in that time it releases as much energy as the sun puts out in 1 year. So much energy that it's carried away by neutrinos. And it's these flares that we see from planet Earth. But not every neutron star has a carbon ocean that ignites frequently. It's necessary for the matter at the point of collapse not to grow quickly. Then there will be an area of particularly high temperature and density. What's also interesting is that on any ocean there are waves. Is it possible for a neutron star to make a big wave in the ocean? Of a neutron star? It's difficult. High density and very strong gravity get in the way. But it is possible to build liquid mountains to keep the matter spread out. The strong magnetic field helps. Of course, on a neutron star, everything happens very fast because of the strong gravity. The gravitational acceleration on the surface is 100 billion times greater than on Earth. That means that a pendulum that swings in 3 seconds on a neutron star would swing in 100,000 seconds on a neutron star. Strong gravity causes elements to rapidly separate into light and heavy elements. In the ocean, the heavier elements quickly go to the bottom and the lighter elements remain on top. This happens over a period of days or months. So the ocean, unless it has convection, is likely made up of distinct layers with different compositions. That is, even if you stir up a stellar Mary, very quickly the neutron mass will still end up at the bottom. This can only be prevented by turbulent mixing, arising from the large temperature difference in different parts of the ocean's surface and the Hall effect. Whatever is in the core of the neutron star, free quarks, condensate of clones, hyperbolas or good old but clones, all this material must hold against the crushing gravity many times greater than the solar. Otherwise the star would slam into a black hole. but different materials can be compressed by gravity to different degrees, which determines the maximum possible weight of a star for a given physical size. Neutron stars are truly amazing objects, but not fortunately, they are very distant and tiny. It's very difficult to measure anything but the most basic properties from them today. What's worse, the most interesting physics is going on beneath their surface. The situation is like a laboratory where something amazing is happening, something secret. Hopefully, with a new generation of equipment, theorists will finally get a real look at neutron stars. Karma constellation, which was mentioned in the films of Claudius Ptolemy, was described in Johann Bayer's famous Atlas of Uranus Meter back in 1603. Picture the constellation of the southern hemisphere of the sky lies on the Milky Way under good observing conditions. In the constellation of Karma can be discerned with the naked eye about 140 stars, 6 of which are brighter than the fourth star magnitude. They form a semicircle in which, with some imagination, you can see the stern of the ship. The most notable object of the stern is the variable star on the whisker. This is the traditional name for this stern. The word means ship in Greek. What is remarkable about this object and why does it attract the attention of astronomers so much? Let's try to explore this question. First of all, we must realize that the star is a stern on a whisker. It is a blue giant, that is, a massive object that is in a certain phase of the dying process. In this phase, the intensity of thermonuclear reactions taking place in the core of the star decreases, which leads to compression of the star. As a result of a significant decrease in the surface area, the density of the studded energy increases, and this, in turn, entails heating of the surface. This kind of compression of a massive star leads to the transformation of a red giant into a blue giant. The reverse process of turning a blue giant into a red giant is also possible, while the stellar wind from a red giant is dammed and slow wind from a blue giant is fast but annoyed. If the resulting compression causes the red light giant to turn blue, then the faster wind collides with and is downed early by the slower wind and causes the ejected material to compact into a thin shell. Almost all observed blue giants have a similar shell, confirming that they were all previously red giants. Because of their huge masses, they have relatively short lifetimes of about 30 million years and are only present in young cosmic structures such as scattered clusters, spiral arms, and irregular galaxies. They are almost never found in the cores of spiral or globular clusters, which are believed to be old objects despite their rarity and their short lifetimes. Blue giants are often found among stars visible to the naked eye, because their inherent brightness compensates for their small number. However, something special stands out among the other blue giants. And even though Bayer in 1603 in his famous Atlas Uranus assigned this star far from the first letter in the Greek alphabet, it is the brightest luminary in our firmament in the constellation Karma. The culprit is Bayer's distinguished colleague, French astronomer and scientist Nicolas Louis de la Capelle. The whole point is that Bayer labeled the stars according to his system in a single constellation at that time, which bore the name Argo, or Ship Argo in honor of the legendary ship Jason and the author. No, it was not the outgoing sailors, so called the participants of the sea voyage. However, this constellation was too large in terms of the area it occupied in the firmament. For this reason, locally in 1752 it was radically divided into sails, keel and stern, which a little later was joined by the compass. That's how this coma and became at that moment the brightest in terms of visibility of the star in the newly created constellation. As for the history of observation of this luminary, it was known in the Middle Ages and earlier to Chinese, Korean, and Japanese astronomers, but did not have any significance for them, being the most common and little subject. Although the Arabs still called it dry hada, which literally translates as the greatest roar or roar of light. It owes its fame in scientific circles and among amateur astronomers to the fact that it is the hottest among all the stars visible to the naked eye in the firmament. Its surface temperature is estimated at 42,000 Kelvin. By comparison, the effective surface temperature of the Sun is only 5,700 Kelvin. This is why the RS takes cosmic gold in the form of the spectral class again. So what else special is known about this leader? The mass of the glowing ball on the USAS is on the order of 45 solar masses at a radius of about 14 radii of our central luminary, suggesting an impressive density of matter on. It is considered one of the most powerful stars in our galaxy in terms of luminosity. Because of its very high surface temperatures, most of the star's radiation is ultraviolet. In the visible range, it's 21,000 times more powerful than our Sun. And if you take the more metric, that is the total luminosity, it is more than 600,000 solar luminosities. If all the radiation in the UCA was in the visible spectrum, then in the Earth's sky, apparently, the brilliance of it would be second only to Sirius, and probably would form in a trio with them the most interesting southern bright stereo in the form of a rectangular triangle. If on this account to fantasize further, then with such a strong radiation and powerful stellar wind, the speed of which is determined at the level of 2,300 kilometers per second, the zone of habitability for hypothetical planets would begin somewhere in the region of 450 astronomical units. Distance from its surface. However, so far neither planets nor any stellar companions have not been detected at this stern, and therefore it continues to be a single star for us. In addition, we have a variable star with a variable network like Alpha Swan or Nebo. The star shows changes in alpha's hydrogen spectral line profiles and X-ray luminosity on timescales of less than a day, which is quite typical of blue giants and giants. But what is even more surprising is that Zeta Coma has a very high intrinsic cosmic velocity and rotational velocity. And this means that we have a so-called running star in front of us. And since so, it may have acquired the necessary for acceleration in space as a result of a supernova explosion in a double system. It is assumed to have originated in what is now the Gamma Nebula, which was the result of a supernova explosion about 2,600,000 years ago. But proving or disproving this claim will be problematic. As for the coming fate of the star, it is worth assuming that it will be on the main sequence for some time, intensively studying and losing mass in the form of stellar wind at a rate of about 1/1,000,000th the mass of the Sun per year. Over the next 101,000 years, Zeta Coma is expected to gradually cool and expand and pass all spectral classes from bits to M as it cools, and then the star's main emission will move into the visible range, but will become one of the brightest stars in the future Earth sky. After 2 million years, the star will have a spectral class of N5, and its size will be much larger than Earth's current orbit. It will then explode, becoming a supernova star due to its short distance from Earth. This supernova will be much brighter than the brilliance of the full moon, and the core of the star will probably collapse into a black hole. It is possible that it will be accompanied by a strong gamma-ray burst, which for obvious reasons we are not destined to see. But the number of stars even within the boundaries of the observable universe is believed to be 10 times greater than the number of stars. A grain of sand on every beach in the world. Of course, even the gaze of the most powerful modern telescopes can see an unimaginably smaller fraction of them. In the search for a stellar leader does not help, and the fact that the largest stars can stand out with their luminosity. Whatever their brightness, it fades when observing distant galaxies. The brightest stars are not the largest, so finding the largest star in the universe will not be as easy as it seems. But what we know already today is awe-inspiring. Before we answer the question, which star is the largest and what is it? Let's take a look at our own sun. The mighty star is 1.4 million kilometers across. The sun makes up 99.9% of all the matter in our solar system. And although there are approximately 1 million Earth-like planets that would fit inside the sun, this star is only a stellar baby compared to other hypergiants. I suggest we look at a list of the 10 largest stars from smallest to largest object. And we'll start with the famous Gates Battery star. This red supergiant is located just 640 light-years away from our planet in the constellation Orion. Its size is 1,180 solar radii. It is believed that Betelgeuse at any moment can be reborn a supernova, and we will be able to observe this most interesting process almost from the first rows. Ninth place G dubbed Lucifer over the dimensions of the fourth representative of the constellation Phae. There is still debate, but roughly the dimensions of this giant are 1,300 solar radii. Eighth place W Sagittarius is located in the constellation Sagittarius. The red supergiant is 3,460 times the radius of the Sun's seventh place Swan. It's a star at least 1,420 times larger than the Sun, but according to some calculations, it could even top the list. The argument is serious. 2,850 solar radii. However, the actual size of the celestial body is likely close to the lower limit, which brought the star to the seventh line of our ranking. The luminary is 5,000 light-years from Earth in the constellation of Swan. Sixth place B30054e. This red hypergiant is quite a bit behind object as many as 64. It's 1,520 times the size of the Sun. The star is relatively close at only 9,000 light-years from Earth in the constellation. Fifth place 0064. It was previously thought that this red hypergiant could rival the Big Dog in size. However, it was recently revealed that it is a star of the Goldfish constellation as well. Only 1,540 times larger than the Sun, the luminary is located outside the Milky Way. There's a big cloud in a dwarf galaxy. Meet the giant star leader, the Shield Giant. The supermassive object is 9,500 light-years distant and is observed as a dim variable star, barely visible in a small telescope. The radius, according to current estimates, is 2,100 radii of the Sun. The size of the object is monstrous. To illustrate, let's take an example. If we imagine our Earth as a buckwheat pizza and the Sun as a watermelon, the diameter of the shield will be comparable to a house with a height of 540 meters or a 45-story house. It would take 8 o'clock to fly around such a star at the speed of light. Recall that there is light, launched by the sun, reaches our planet in only 8 minutes. If you fly at the same speed at which the ISS for an hour and a half makes one revolution around the Earth, the flight around its shield will last about 36 years. But what's interesting to note is that the monstrous size of its shield is completely incomparable to its other parameters. This star is only 10 times more massive than the Sun. It turns out that the average density of this supergiant is almost 1 million times lower than the density of the air around us. For comparison, the density of the Sun is 1.5 times the density of water, and a grain of matter of a neutron star weighs 1 million tons. Roughly speaking, the average matter of such a star is similar in density to a layer of atmosphere located at a height of about 100 kilometers above sea level. This layer, also called the pocket line, is a conventional boundary between the Earth's atmosphere and space. It turns out that the density of the shield is only slightly less than the cosmic vacuum. It feels like a star about to burst. Nor is the shield the brightest. With an intrinsic luminosity of 340,000 solar luminosity, it is tens of times dimmer than the brightest stars. A good example is star 106, which is the most massive star known today at 265 solar masses. At the same time, the star is only 36 times larger than the Sun. It turns out that 106 is 20 times brighter and about the same number of times more massive. And the shield, while 50 times smaller than the giant. Yes, as you might have guessed, her shield is nearing the end stages of its evolution. Like all giants, it has begun actively burning helium and some other heavier elements. According to current models, in a matter of 1 million years its defense will successively turn into a yellow giant, then into a bright blue variable or wolf heaven star. The final stage of its evolution will be a supernova explosion, during which the star will shed its shell, most likely leaving behind a neutron star. Already today, its defense is already showing its activity as a regularly variable with an approximate pulsation period of 740 days. Given that the star can change its radius from 1700 to 2100 solar radii, its rate of expansion and contraction is comparable to that of spacecraft. Its mass loss is at an impressive rate of 58 million solar masses per year. Yes, the star is the largest known star. Its size is truly shocking and terrifying. It's hard to imagine that there are even bigger stars. All of the objects discussed today are highly unstable and short-lived. Such stars can live for as little as 1 million or even hundreds of 1,000 years. Therefore, observing a giant star in another galaxy, we can be sure that now, most likely, in its place is a pulsating neutron star or even a space-bound black hole surrounded by the remnants of a supernova explosion. Be such a star even 1,000 light-years away. One cannot be entirely sure that it still exists or has remained the same giants. Back in 1950, Jan Ward, an astrophysicist from Holland, opined that all comets form in the same place, a kind of cloud surrounding the interior of our solar system. It is not uncommon to observe celestial bodies in the vicinity of the Sun. The matter of which in the vicinity of the hottest star is vaporized and carried away from it by cosmic winds. These vaporized and celestial bodies are comets. Evidence that the comet keeps its way from very distant parts of the solar system is their elongated shape of orbits. Every year, astronomers record the movement of about a dozen such comets. But do all these objects actually appear in the distant cloud that is believed to surround the outer part of the solar system? In order to find out the answers, we propose to take an amazing journey. The solar system ends where the gravitational influence of the Sun compares to that of its neighboring stars. That is, about midway between the Sun and the nearest stars. Accordingly, if the distance to the nearest stars is light years, then the solar system is of the order of a few light years in size. Thus, the solar system is a very large formation, 1,000 times larger in size than the orbits of the most distant planets. And we will have to wait tens of 1,000 years for the Voyager probes to fly beyond the boundary of the solar system. It would also be correct to say that the boundary of the solar system is conventionally delineated by the Oort cloud. The estimated mass of the cloud to date is only a fraction of the ejected material at 80 Earth masses. Yes, it may not seem like much. However, the Oort cloud is actually a giant sphere of scattered, filled material with a diameter that is staggering. Some astronomers estimate that this region begins at a distance of 2,000 astronomical units from our star and ends at a distance of about 70,000 astronomical units. 1 trillion. From time to time, some of them move back toward the Sun and take the form of a comet. The Oort cloud is thought to include two distinct regions: the spherical outer Oort cloud and the disc-shaped inner Oort cloud. Objects in the cloud are largely composed of water and ice. It is likely that the objects formed near the Sun and were scattered far out into space by the gravitational effects of the giant planets. In the early solar system, although there have been no confirmed direct observations of the Oort cloud, astronomers believe it to be the source of all periodic comets and comets. Galileo of this type, as well as many centaurs and comets of the Jupiter family. The outer part of the Oort cloud is the approximate boundary of the solar system and can easily be affected by the gravitational forces of both passing stars and the galaxy itself. These forces sometimes cause comets to head toward the central part of the solar system. Short periodic comets, based on their orbits, can originate not only from the scattered disk, but also from the Oort cloud. We've already mentioned that the Oort cloud has a huge amount of material, but what is it? 1 trillion, 1 million. Incidentally, Halley's Comet is a suitable prototype for all comets within the outer Oort cloud. The estimated combined mass of all the large comets in the cloud is about 5 times the mass of the Earth. The mass of the inner Oort cloud is currently unknown. Comet bodies can spin in the Oort cloud for long periods of time, can be ejected from the solar system, or can rush into the vicinity of the Sun, becoming true tail comets. Comets aside, the vast majority of Oort cloud objects are made up of various ices formed by substances such as water, methane, ethane, carbon monoxide, and hydrogen. However, the discovery of a 1996 W asteroid object with an orbit more typical of periodic comets suggests that there may be rocky objects in the Oort cloud. Here is an example. An analysis of the carbon and nitrogen isotope ratios in the chambers of both the Oort cloud and the Jupiter family shows only slight differences, despite their very separate regions and origins. It is concluded that the objects of these regions originated from the original protosolar cloud. This conclusion is also supported by particle size studies of the Oort cloud committees. It is also surprising that gravitational interaction with neighboring stars and galactic tidal forces have changed the comet's orbits, making them more circular. This explains the almost spherical shape of the outer Oort cloud. which means that the Hills cloud, which is more strongly bound to the Sun, should still eventually acquire a spherical shape. Recent studies have shown that the formation of the Oort cloud is definitely compatible with the hypothesis that the solar system formed as part of a star cluster of 200,400 stars. These early nearby stars likely played a role in the formation of the cloud, as the number of close passages of stars within the cluster was much higher than today, leading to much more frequent perturbations. The current positions of most comets seen near the Sun are thought to be due to gravitational distortion of the Oort cloud by tidal forces caused by the Milky Way galaxy. Similarly, the tidal forces of the Moon bend and distort the Earth's oceans, causing tides in the inner solar system. These effects are minor compared to the Sun's gravity, but the Sun's gravity is weaker in the outer solar system, and the gradient of the Milky Way's gravitational field plays a much more significant role. Because of this gradient, galactic and tidal forces can distort the spherical Oort clouds, stretching the clouds toward the galactic center and compressing them along the other two axes. These weak galactic perturbations may be sufficient to dislodge Oort cloud objects from their orbit toward the Sun. There are, by the way, curious calculations, according to which during the existence of the planetary system, alien stars have passed through the inner rock bank 10 times, causing an increase in the frequency of comets by 1,000 times. Such an event lasts about 400,000 years. During this time, up to 200 comets fall to Earth at an average of 1 comet per 2,000 years. On the scale of human life, of course, this is not particularly tangible, but on a geologic scale, we can talk about comets. Such showers even try to connect with the mass extinction of species on our planet. In addition, the clue to the periodicity was explained by the existence of a non-miserable dark star with a mass of several hundred solar. And Isis, according to this hypothesis, moves around the Sun in an elongated orbit and every 26 million years enters the comet clouds. However, the station Pioneer 10, being on the outskirts of the planetary system, did not experience any additional acceleration that could be explained by the influence of a non-minor, or at least major planet the size of Jupiter. Although the influence of a body of 3-5 Earth masses cannot be ruled out. So, the Oort cloud is a really interesting and poorly understood region that contains tens of 1 trillion rock cores. Some of them we have already seen, others we have yet to see. Look at the night sky, especially if it's a clear night sky with no clouds. And you're far away from any city lights. You look up and see countless beautiful stars. And while we know that stars are massive and swirling clouds of hot gas and dust, they look pretty spectacular. But 1 billion light-years away, things aren't quite so simple and reassuring. It may be pretty hard to imagine, but a fairly large percentage of stars in the night sky are waiting for or have already experienced a cosmic collision. Although, from our point of view on Earth, stars look fixed, they are actually moving quite rapidly in outer space and have a good chance of colliding with another massive body. The universe is like a giant pool table in this sense. Collisions in space can happen among any body, be it a star, asteroid, comet, or planet. The result becomes a spectacular event consisting of bursts of energy and matter. But what does happen when stars collide? Are collisions in space rare events, or do they happen quite often? Can the Earth or the solar system suffer from such collisions? Let's try to understand. So, star collision is a process in which two stars approach each other and under the influence of gravity merge into one object of large size. According to astronomers' calculations, such events occur more often in globular star clusters in our galaxy with a frequency of about once every 9,000 years. Most recently, astronomers were able to observe such a collision of stars. But a series of stellar collisions within a dense cluster in a short period of time can even lead to the emergence of a black hole. However, any star in the universe can collide with another star, regardless of whether it is still alive. That is, the processes of thermonuclear fusion still occur in the core or is already dead, and the fusion processes have already exhausted themselves. Such objects can be white dwarfs, neutron stars, black holes, main sequence stars, giants and supergiants. And the difference in the types of stars in their mass, temperature, and radius leads to different types of collisions or fusion. For example, white dwarf stars, consisting of electron nuclear plasma, devoid of thermonuclear energy sources and glowing due to their thermal energy, cool down strongly gradually over a period of 1 trillion years. In simple words, they are the remnants of low-mass stars. If the white dwarf is part of a double system, it may drag matter from the companion star as a result of aggression. For example, it could be a red giant. Such a main sequence star. Thus, the mass of the white dwarf will increase and at some point may exceed the so-called Icarus limit. That's the upper mass limit at which a star exists only as a white dwarf. All this will lead to its gravitational collapse and the subsequent supernova explosion. However, when two white dwarfs orbit each other in close orbits, the emission of gravitational waves reduces the momentum of the system and forces the stars to approach each other in a spiral. If during their merger the total mass exceeds the Chandrasekhar limit, neither the thermal pressure nor even the pressure of the forced electron gas can balance gravity, and gravitational collapse occurs. It causes the density and temperature in the interior to increase and the nuclear combustion reactions of carbon to begin, causing the temperature to rise even more. The increase in temperature accelerates the nuclear reactions, but does not lead to an increase in pressure and expansion of the star, because the matter in white dwarfs is in a forced state. The process becomes a chain-like acceleration. The nuclear fusion reaction rapidly heats the interior of the combined star, and this also leads to the explosion of a nova or supernova, forming a residual neutron star in the center. Within seconds, all of the star's matter is blown apart in space, but sometimes the merger of two white dwarfs can form something more unusual. That's what happened in 2017, when researchers discovered an X-ray source that looked like a white dwarf, but was too bright to be one. It was hypothesized that the object could have been an unstable merger of two white dwarfs. In the new study, the team used the Ham-Newton X-ray telescope, and the new data confirmed that the object has a mass of attention beyond the limit. Hendrix Icarus. It is surrounded by a residual nebula that is mostly made up of neon and is green in color. This is consistent with the object being created by a white dwarf merger. It probably has a high rotational velocity, which prevents the object from collapsing into a neutron star. But eventually this object will collapse and become a neutron star over the next 9,000 years. A supernova is likely to form during this event. It looks like a white dwarf can overcome the limit of Icarus' penis, but only temporarily. And what can be said about neutron stars? Yes, they can also collide with each other, and the process resembles the scenario by colliding two white dwarfs. When two neutron stars orbit around each other, they eventually spiral out of gravitational radiation. When they meet, their merger results in the formation of either a heavier neutron star or a black hole, depending on whether the mass of the remnant exceeds the Oppenheimer-Volkoff limit. This creates a magnetic field that is 1 trillion times stronger than Earth's, in 1 or 2 milliseconds. It's this type of event that is believed to create short gamma-ray bursts as well as new stars. Although new stars aren't really stars, it would be more correct to say that they are astronomical events that occur in double star systems. When two neutron stars or a neutron star merges with a black hole, the body of the new event is the source of strong gravitational waves as well as the source of strong electromagnetic radiation during the merger of two compact stars. The fusion of heavy ions takes place as a result of the process of neutrons being captured by nuclear. The new body is one of the main sources of elements heavier than iron. Such a vast cosmic forge of atoms. Also, we cannot fail to mention a known, though still hypothetical object known as the Thorn liquid object. It is believed to be one of the strangest stars in the universe. Formed when a neutron star hits a red giant. Nearly half a century ago, physicist Kip Thorne suggested that a strange star like a cosmic nesting doll could be lurking in space, just waiting to be found by those who know how to look. Astronomers have named these theoretically stellar hybrids Thorne objects. The possible existence of such objects became known when computer modeling was done, revealing that a neutron star is a tiny superdense stellar star, a remnant left behind. When a star goes supernova, can be swallowed up by a red giant star. According to modeling, if the two objects go too close together, instead of ejecting one star, the two stars could merge. A neutron star the size of a city with a solar mass would live inside its much larger host, almost like a cosmic parasite. But even if physics does allow for the existence of such stars, finding them would be difficult. In a study published back in 1975, Thorne and Jidkoff suggested that these stars would look almost identical to red supergiants, such as Chase's battalion in the constellation Orion. Like giant stars are relatively common and are among the youngest and largest stars in the universe. Thorne objects would be very similar to red supergiants, but presumably with a longer lifespan of about 10 times longer. And what about collisions in our solar system? Whereas in some parts of the galaxy, star collisions are quite common, the probability of the Sun being involved in this event is very small. Calculations show that a collision between the Sun and another star can happen once every 10/28 degree of a year. For comparison, the age of the universe is on the order of 10/10 of a degree of years. So the probability of other stars approaching the Sun is also small. Despite the low probability of the Sun being directly involved in such an event, Earth could be affected if such a collision were to occur relatively close by cosmic standards. According to modeling, if a star collision were to take place within 100 light-years of Earth, it would destroy the Earth and all who settled on it. The spacecraft, which were launched back in the days of Star Wars Episode 4, have survived dozens of malfunctions and more than 40 years in a vacuum at temperatures just above absolute zero. Many times their mission has been called into question, and despite everything, they still remain in service. Still, time marches on, and even the creators of these vehicles are now in their old age. Of course, spacecraft will undoubtedly survive many more generations. As 1,000 years pass, they will not stop moving through space. Where will the vast depths of space take them? That's where the satellite can help us. It has information on the positions and movements of more than 7 million stars. Astronomers have calculated with which of them the closest astronomical time will meet spacecraft Voyager 1, Voyager 2, Pioneer 10, and Pioneer 11. It appears that the action will be long. Perhaps when we have more information about the population of the Milky Way, we will be able to identify more interesting close flybys of not only stars, but also planets, comets, and asteroids. As we know, the closest of Galileo's four satellites, Io, is radically different not only from the other satellites of Jupiter, but in general from all satellites of other planets in the solar system, as well as asteroids and comets. It doesn't have the usual mountains, valleys, and craters. It is in general the only rocky celestial body known to astronomers on which there is not a single crater, no water in liquid or solid form. The violent, turbulent world experiences constant violent volcanic eruptions, sometimes several at a time. In all, Io now has more than 400 active volcanoes. The surface of the satellite completely changes every couple of 1,000 years. The red-hot satellite is constantly being squeezed by the gravity of the huge planet. We on Earth are used to our moon's gravity lifting the water of the world's oceans to cause the tide to rise. Now, on Io, the tide is 1,000 times stronger. The gravity of Jupiter and the other satellite of Europa lifts not the water but the solid crust of the satellite by hundreds of meters. Every day, according to conventional theory, the activity is due to the periodic heating of the interior of the satellite as a result of friction that occurs when the crust moves due to the tidal gravitational effects of Jupiter. Jupiter's gravity is so strong that the crust is torn apart. It's also moving relative to the mantle. The friction between the crust and the mantle causes the rock to split apart into liquid magma. The rock in liquid form increases in volume, hence the constant eruptions. It was previously thought that magmas formed only in isolated pockets between the solid crust and mantle. But recent observations have forced a rethinking of the classical model. If everything was according to the model, we would observe volcanoes in certain areas of the surface according to Io's location relative to Jupiter and Europa. The discovered object was initially thought to be a comet, announced on October 25, 2017, and given the comet designation SI 2017-1. Even then it was already known the unusual hyperbolar, orbit, and attempts to confirm comet activity on the same day. Unscheduled observations were carried out on a very large telescope with Camera 2 on the program Urgent First Interstellar Object in the Solar System. But the deep combined images obtained did not show a copper coma. That is, the gas shells around the core. Accordingly, the 2017 one was renamed 2017-1, becoming first a comet at first, but then changed to an asteroid. The team working under the Pan-STARRS program gave the discovered object its own name OMO or Omer, which means scout or coming from afar in Hawaiian. It is worth noting that the option of naming the temple after an alien ship that was discovered under similar circumstances was also considered. Arthur C. Clarke's science fiction novel A Date with Rama. So, discovered as the first interstellar object created by its existence for the International Astronomical Union, some precedent in terms of its designation. For this purpose, a special index was introduced for it and similar other interstellar objects. The capital letter of the Latin alphabet RE is an abbreviation of the English word interstellar, which means stellar, eventually assigned the final name. 1. 2017. 1. Researchers had previously hypothesized that the interstellar guest was composed of rock and had an elongated cigar shape, a similar shape of 300 meters long and 30 to 40 meters wide. However, another group of astrophysicists came to a different conclusion, that the Embark object has a much flatter shape, something resembling a pancake or a grain of sand. Cosmic, of course. For all that, the object continues to deplete over time. But the new data didn't stop there. Using the William Herschel Space Telescope, a spectrum of the object was obtained that indicated a uniformity of red color across its surface, similar to many of the objects that populate the Kuiper search. The red color of cosmic bodies is transformed as a result of the radiation received by cosmic rays, particularly high-energy particles, protons. In addition, the color can also be explained by the presence of a strongly selected surface. Nevertheless, the researchers state with almost certainty that the mysterious object from heterogeneous in ice. They have calculated how quickly such ice should with cold to tear, that is, to change from a solid state to a gas, while passing by the sun. The mass repulsive force, shape, objects, and albedo were also calculated. Reflect the ability of ice. Astrophysicists then compared the data obtained with the characteristics of different ice and concluded that the most accurate matched them only one ice solid and nitrogen. Such material is familiar to scientists as it is observed on the surface of Pluto. Therefore, the authors of this hypothesis believe that it may consist of exactly the same material. The researchers also calculated the speed at which chunks of solid nitrogen ice could have broken away from the surface of Pluto and similar bodies during the formation stage of our solar system. This led them to conclude that it could have been part of a planet similar to Pluto, but located in another star system. But a little later, on June 20, 2018, astronomers announced that Cupid is still more of a moderately active comet than an asteroid. This was determined by measuring a non-gravitational increase in the object's acceleration, which is consistent with the comet's degassing model of the object's velocity. Strong influence had our Sun flew closer to it, the object began to accelerate and, as if given, nodded everything from it. And this push with acceleration was more powerful than could be explained. At the same time, the object did not have a tail, typical for comets. So the question of what the object AMO again hangs. And we will continue to investigate. This space object rotated in space along three axes during the time that, like in Arcadia, the period of such a circulation of mu lies within 7 to 8 hours with an amplitude of brightness of 1.80 stellar magnitude. The dry surface, unusual shape, and mysterious trajectory have even led some researchers to wonder if this object is a probe of an alien civilization. But it is hard to believe that inside this object sits aliens. Yes, it is indeed a mysterious object, but some clues such as its color and lack of radio emission indicate that AMO is still a naturally occurring object. A little later, a computer model or scenario was developed that explained the nature of the characteristics of this object and its amazing features. The scenario showed that AMO was actually a fragment of a planetary body that came very close to the star and then was torn apart by tidal forces. The fragment was ejected in the interstellar and space turbulence flow. When bodies fly past a massive object, they are subjected to powerful tidal forces. The gravitational field of the star attracts the object so strongly that it can deform and even collapse. This effect was observed, for example, In 1990, when Lebedev's comet Shumiko came too close to Jupiter and tidal forces shattered it into 21 separate fragments. All of the comet's pieces crashed into the gas giant's atmosphere. In their model, the researchers simulated how icy or rocky chunks of different sizes deform and then collapse as they come close to the star. The simulation showed that tidal forces at such close distances from the star can not only tear the object apart, but can also form into elongated, flat fragments such as AMO. Such a shape arises because smaller fragments are heated and merge under the influence of tidal forces. At the same time, these fragments accelerate to the point where they are able to break out of their planetary system. The speed of the interstellar in space y is nearly 30 kilometers per second, but the Sun's attraction has eventually caused it to accelerate to a maximum speed at perihelion of 88 kilometers per second. Having passed the peak of its hyperbola from the orbit, the object slightly changed the direction of motion and, passing under the orbits of Mercury and Earth, again crossed in the opposite direction of the ecliptic planes in the space between the orbits of Earth and Mars, now leaving our solar system in the direction of the constellation Pegasus. Further, the speed of AMO will slow down to the speed at which it arrived in our system. It is assumed that the object will finally leave our system in about 20 years. It is not known how long AMO has been traveling among the stars. It could be hundreds of 1 million or even 1 trillion years. After calculating the proper motion of the object, astronomers concluded that it was traveling in our direction from stars in the constellation Lyra, such as Vega. Its path would have been on the order of 600,000 years. However, 600,000 years ago, Vega and other neighboring stars were quite different from where or through which AMO flew. Therefore, it is currently assumed for the moment that it was thrown out of one of the star systems in the constellation Keel about 45 million years ago, which has now shifted noticeably southward in our sky during that time as a result of the process. Given all the unique properties of this interstellar object, the logical question arises: why not send a probe to itself and check if it is a ship of an extraterrestrial civilization, an alien probe of a comet or asteroid Ida October 30th, 2017. The Lyra C mission project was designed to build a probe and send it to the then flying Momo. The problem is that this interstellar object was detected when it was already on its way, fleeing the solar system. And it's moving very fast at 88 kilometers per second. Even the fastest spacecraft ever built by man, which is the Parker probe, has a top speed of about 95 kilometers per second. Planning and equipping an exploratory space mission is a complex and time-consuming process. If you look at it realistically, to equip the mission, it will take, according to the most conservative estimates, at least 5 years. And besides technical and scientific issues, there is also a financial issue. And such missions are very expensive. Even if we build a vehicle that can move twice as fast as the Parker probe, it will still take it 10 years to catch up with the WMD. And by then it will be so far away from the Sun that its energy will be practically useless. To keep the vehicle functioning, it will need to use an isotope electric generator. The duration of such generators is tens of years. True, over time, the energy output of the generator falls. But there is no need to be sad. In fact, the chances that this particular object is somehow related to extraterrestrial civilization are so small that no one would want to spend so much time and money to organize a complex, expensive, and lengthy mission just to make sure of it. If Nuama had been discovered on its approach to the solar system, for example, a few years before it passed the point of its maximum approach to the Sun, then it would have been a different matter. and it is quite likely that a mission to him would have been organized. Of course, not to test the hypothesis of its alien origin, but because the study of interstellar asteroid itself is of great interest. Having calculated all the risks and possible costs, which is hundreds of $1 billion or even $1 quadrillion, the Project Lear was closed. At the same time, the asteroids are so highly dispersed in this area of space that no spacecraft that has come through this area has been damaged by them. Incidentally, the first spacecraft to fly through the asteroid belt was Pioneer 10, which reached the main belt region on July 16, 1972. This was followed by Pioneer 11, Voyager 1 and 2, and the Willis probe, all of which flew through the pole without planned or accidental approaches to the asteroid. The Galileo space probe was the first spacecraft to take pictures of asteroids Gaspar and Ida, after which NASA adopted a program according to which any spacecraft flying through the asteroid belt should, if possible, fly past an asteroid. Thus, in the following years, space probes have received images of numerous objects inhabiting this region of the solar system. And on September 27, 2007, the main mission to visit the asteroid belt was sent automatic interplanetary station Dawn to study the largest asteroid in the solar system, Vesta, and the dwarf planet Ceres. The Dawn mission was the first to explore more than one celestial body from orbit, as well as the first spacecraft to orbit a main belt asteroid and the first to orbit a dwarf planet. So, after the start from Earth apparatus, Dawn made a gravitational maneuver around Mars with a set of speed and went to the asteroid belt, where it arrived in August 2011. And then the apparatus entered the orbit of Vesta. The entire asteroid belt is conditionally divided into an inner and outer area. Ceres is in its outer part, and Vesta in the inner, becoming for this reason the first object for study. May 3, 2011, he took the first photo of Vesta from a distance of just over 1 million kilometers, after which the active stage of study of this asteroid began. June 27, the apparatus reduced speed, getting closer and closer to Vesta, and a month later made almost 2 revolutions around the Sun. The apparatus reached Vesta and moved into its circular orbit with a height of 16,000 kilometers. The spacecraft spent the entire month of July taking pictures of Vesta's surface. In September, the spacecraft descended further down to a high mapping orbit at a distance of 680 kilometers from the surface. At that time, the second intensive phase of work began, which lasted 1 month. During this time, about 60 revolutions were made, 6 cycles of imaging at different angles. On December 8, the spacecraft moved to a low mapping orbit with an altitude of 210 kilometers, where the next 10-week phase of work began. The main research program Dawn was completed. The probe remained in low orbit for some time to collect additional data on the surface composition and gravity field, then moved back into high orbit to study in more detail the northern hemisphere, which had not been illuminated by the sun before. The probe confirmed how large the Sylvia impact crater in Vesta's southern hemisphere is, about 500 kilometers in diameter and 19 kilometers deep. The spacecraft also showed that the mountain, which was once captured by the Hubble telescope in the center of the huge crater, is more than twice the height of Mount Everest and is the second tallest mountain in the solar system, behind the Martian Olympus. On closer inspection, the probe found a second large impact basin, now called the Accusations, partially covered by a younger basin. Whether these 1 or perhaps 2 impacts altered Vesta's surface and probably nearly destroyed it. It remains a mystery how Vesta was able to survive such a monstrous cataclysm. It is likely that numerous H5-class asteroids or debris scattered after this collision giant impacts created dozens of canyons. Detected in the probe images of the belt equator of Vesta. Some of these canyons rival the Grand Canyon, measuring up to 465 kilometers long and 4 kilometers deep. These probes also show the massive impact that formed Russia just 1 trillion years ago. Thus, the surface of the southern hemisphere looks younger than the northern hemisphere, where a huge number of craters have been preserved. Early researchers thought Vesta was a generally dry object, but the spacecraft found water-saturated minerals associated with carbon-rich material on Vesta's surface. These materials were likely delivered to Vesta by asteroids or comets from the more volatile-rich outer solar system. Having completed the extended program on September 5, 2012, the device left the orbit of Vesta and headed for the next object of study of Ceres, the transition to which took 2.5 years and now 6 March 2015. Having covered a total of almost 5 billion kilometers, the device was captured by the gravitational field of the dwarf planet at a distance of 60,000 kilometers from it. And in early June, the first photographs from a distance of 4,500 kilometers from the surface have already been obtained. While the probe's observations of Vesta confirmed existing hypotheses, providing more details to fill in the gaps, and Ceres much less was known. In fact, most of what we know now of the dwarf planet was provided by the Dawn spacecraft. Initial calculations suggested that Ceres might be divided into layers, although the composition of these layers was unknown prior to the probe. With a low average density, Ceres was expected to have a large amount of water ice beneath its surface. But the probe's measurements confirmed that Ceres is actually composed of a rocky core and a crust of water ice covered by a dusty outer layer. The Dawn spacecraft also found evidence of so-called crust hydrates of gas trapped in the crystal structure of water molecules, which contribute to the surprising strength and low density of Ceres' crust. While most of Ceres is relatively smooth due to its liquid surface layer of ice in space, the spacecraft detected one large mountain that could not be seen before. This mountain is about 4 kilometers high, named a Huna Mons Dome, a figurative shape similar to volcanoes on Earth, suggests that it probably formed from a curve of conical activity. Although curved volcano will be able to be present on other icy worlds. The spacecraft's observations make Mount Huna the closest known volcano in the solar system. Again, Hubble images previously showed the presence of several brighter regions on Ceres' surface. But when the probe moved to a lower orbit, it found hundreds more such areas than were captured in the original images. These spots turned out to be reflections of salt that was likely left behind when salt water escaped from beneath Ceres' surface and others. Observations by the Herschel Space Observatory showed a small amount of water vapor around some of Ceres' particles, which led to speculation that it might have a weak atmosphere or even ongoing conical activity curves. The probe found that this gas could be the result of the Sun's particles colliding with water ice on Ceres, which is then released as vapor, leading to a temporarily weak atmosphere spectroscopy. Data from the Dawn spacecraft also confirmed the presence of ammonia on the dwarf planet's surface. Conditions in the main asteroid belt are too warm for ammonia to form, which requires much colder conditions, raising questions about its origin. Ceres was able to form much farther out into the colder outer solar system before migrating to its current position, or the ammonia could have been transported to the medium by bodies from the outer solar system. The spacecraft also confirmed the presence of Ceres carbonate, which had been detected 10 years earlier by the Pechersky telescope, a large number of them further confirming the existence of an ocean in the early history of Ceres. This dwarf planet may even be warm enough to have a small amount of remaining liquid water beneath the surface. Well, the Dawn mission has shown us how important the birthplace of bodies was in the early days of our solar system. Understanding the environment in which the smaller planets were born is crucial to understanding their fate. Early models of the solar system and planetary migration must now take into account the findings of the probe's several years of operation. Vesta, which probably formed in the interior of the solar system and stayed there, evolved in many ways similar to other planet. Mapping of Vesta's craters revealed that the asteroid's northern hemisphere is an ancient surface that was hit harder than expected. This suggests that there were more large objects in the past, and also suggests that the planet Earth-like type of smaller bodies that may have evolved into planets were already born large, rather than being built from smaller blocks. Ceres, on the other hand, is an important piece of the puzzle of oceanic worlds with a crust that mixes ice rocks to form minerals and other materials. Ceres appears to be a remnant of an oceanic world carrying the chemical composition of its old ocean. Ceres can tell us about the environmental conditions on other worlds with oceans. By the time the main mission was completed, the spacecraft had traveled a total of 5.5 billion kilometers, making 2,450 revolutions in orbits around Vesta and Ceres. During that time, it collected 132 gigabytes of data and captured 69,000 images. November 1st, 2018. The Dawn spacecraft, transferred to a stable orbit, exhausted all maneuvering and attitude control propellants, and the 11-year mission was officially over. In its final orbit near Ceres, the apparatus will remain uncontrolled for at least another 20 years. With a 90% probability of no more than 50 years it will circle Ceres alone. Amazingly, for 2 centuries, the dwarf planet Ceres and Vesta seemed nothing more than dim points of light among the stars. Until the Dawn mission presented us with a detailed portrait of these 2 complex and fascinating alien worlds. The composition of minerals on the asteroid's surface is similar to that found among the meteorites of the Candrix. This suggests that Eros is the original building block rather than part of a larger body. Eros appeared to be a tiny world with an undulating horizon, craters, waves, and valleys. The spacecraft's 3-dimensional images show no contrasts between light and dark and allow us to estimate the size of structures on the surface. The smallest details are about 30 meters in size. On February 12, 2001, the Munir probe managed to land on the surface of the asteroid. During the descent, the device transmitted highly detailed images of the surface. The last image was taken from a height of 700 meters and covered an area 33 meters wide. During the landing, the probe's speed was reduced to 5 kilometers per hour. It left its orbit and descended to the surface of the asteroid. The probe successfully landed on the distant asteroid and stood firmly on the ground in a 10-kilometer shallow notch in the central part of the asteroid. Surprisingly, a landing on Eros was not originally planned. Its idea appeared when the apparatus had exhausted its resource and had to be abandoned in space. But despite all the fears, the probe not only successfully performed the most difficult maneuver, but also continued to transmit valuable scientific information to Earth. Descending, the device continued to shoot the surface of Eros with unprecedented for that time resolution. During its 1 year of operation alone, it provided researchers with valuable information and sent more than 160,000 photographs. Since the apparatus was not prepared and adapted to work on the surface of the asteroid, it operated on it for just over 2 weeks. transmit data back to Earth. And as early as February 28th, the missionary was committed, and it would seem that the heat disappeared in the darkness of deep space. They still make themselves known after years of silence. Moreover, when new data comes, it is a real discovery. For example, just recently, at the time of flight, in the intervals between emissions of solar radiation, found a very weak and monotonous constant signal in a narrow band of frequencies. It is possible that this goal is related to other waves caused by perturbations in the interstellar gas of the interstellar medium, similar to silent rain. In this case, solar flares are like lightning during a thunderstorm. And then the light rain begins again. What could it be? Let's try to figure it out. The point is that low levels of activity in the interstellar medium are higher than expected. For a nearly complete vacuum, it's not entirely clear what is causing this activity. It could be thermal, active plasma oscillations, or quasi-thermal noise from the motion of electrons in the plasma creating a local electric field. Perhaps the aliens are taking the probes apart, hoping to find a representative of Roscosmos there. But whatever the cause of this hum, it can be used to estimate the plasma density distribution of interstellar space. Theoretically, we know that interstellar space isn't completely empty. But because the stars are so bright, much dimmer, thinner, the material that hangs between them is really hard to see and measure. There seems to be an increase in electron density on the other side of the pores. Both Voyager probes detected this when they passed through it more accurately. Knowing the density of the interstellar medium will help us understand why the researchers hope that continuing to study these moles will allow them to not only track the plasma distribution space of the interstellar medium, but also understand how this medium interacts with the solar wind and as a protective bubble. Alios, the solar system's spheres are shaped and modified by the interstellar medium. But by now, NASA engineers have been forced to shut down almost all scientific instruments, leaving only those capable of studying plasma and magnetic fields. By 2025, there will be no energy left in the hearts of the two wandering brothers. Not even to communicate with the Earth. And before their hearts stop forever, the scientists will let Roger say his last words to them, establishing a farewell connection with them in order to get all the data they can from them. But still, the radios flooded the first electrical generators and will still continue to give off heat for 10 half-lives or 880 years after launch in about 2800. The plutonian stockpile will finally be depleted. And that's when we can say that the fats will just turn into iron. Traveling through the vastness of the Milky Way in about 20,000 years will reach the Oort cloud. And this will probably be the main obstacle on their way, as a lot of rocky icy debris can significantly damage and even destroy the device. But let's hope that our supporters will be lucky and they will safely get out of the abode of comets. And then their paths will finally separate. Voyager alone will go to meet 445 red, dim and cold dwarf, whose luminosity is 120 times fainter than the Sun's, and whose temperature is about half that of the Sun. It is not known whether there are planets near this star, but even if there is someone living there, it is unlikely that these creatures will be like us. There's one that will pass 1405, almost 2 light-years away. That would be the maximum point of convergence. And it's 40,000 years away. Yeah, not soon enough. What about Voyager 2? After the same time, it will visit another dim dwarf called 248, and they'll be only a light-year and a half apart. And then, nearly 600,000 years later, it will reach the Sirius system. But what will they see? Unfortunately, We'll never know. And will humanity even exist by then? But the truth is, they will. Holes can become objects that have outlived not only their creators, but perhaps the entire humanity, including 1 billion years, if they do not collide with anything, will wander the vastness of the Milky Way and rotate with other spacecraft of other representatives. Maybe someone will find them and be able to decipher our messages? Perhaps. And when the Earth will be burned by the heat of the sun, our technology will carry the memory of us through time and space. Technology is an extension of the human hand and the power of our intellect, our science and knowledge. Even if they are imperfect. And we still have much to learn. It is our voice on the road to knowledge. And as long as there will live Voyager until their alien debris is destroyed and not fused by galactic radiation, the word of our civilization will live on. On August 13, 2018, NASA's unique solar probe Parker was launched. To date, moving political orbits that in April slightly beyond the orbit of Venus for gravitational maneuvers. The probe has already completed 13 revolutions. When the probe gets as close to perihelion as possible, its heat shield will heat up to 1,400 degrees Celsius, which is about 3 times the temperature on the sunlit side of Mercury. Nevertheless, the probe will continue its work in the space lamp. The fact is that the heat shield do not kill consists of 3 layers. The middle layer is represented by 11 centimeters of lightweight carbon foam. The outer surface is covered with a thin layer of light-reflecting ceramic material, which is not destroyed by high temperatures and radiation. It is a kind of beach umbrella that covers the device from the warm sun. As for the scientific instruments mounted on the umbrellas, in brief, they are designed for large-scale experiments. The main objectives of which are to determine the structure and dynamics of magnetic fields in the sources of solar wind and to identify the level of energy and descended by the sun's corona. So, what do we know about the work done by the space probe Parker and what data he has already managed to collect to date? We propose to go to the hottest moments of the mission. As we know, already in November 2012 approached our luminary at a distance of 8.5 million kilometers, touching the solar corona of the upper, the most resolved and hot layer of the sun's atmosphere, consisting of plasma. After processing the transmitted data, it turned out that the probe flew under the albedo surface 3 times. This part is considered the boundary between the solar atmosphere and the flow of free solar wind. Solar material with the energy to extend this boundary becomes the solar wind, which entrains the sun's magnetic field as it rushes through the solar system to Earth and beyond. The solar wind does not now relate to the sun's atmosphere the moment the interstellar plasma is stronger than the solar wind, to be considered the boundary of the solar system. So, Parker's measurements found that Albion's surface is located an average of 13 million kilometers from the center of the star. The boundary of these waves is uneven, and its height can change over time. In addition to this, the probe discovered many other phenomena. For example, one of the earliest was the detection of a dust-free zone closer than 6 million kilometers to the luminary. Cosmic dust. Most of it evaporates, including Earth's dust. Let's take a note of that. In the spring of 2022, Peter Parker made an image of the solar corona, which showed a distorted, a kind of so-called shaped fracture of the coronal plasma. It was found that this phenomenon was observed over an active region labeled WASP 12972, which is a collection of changing structural formations in a limited region of the solar atmosphere in which there is a change in the magnetic field. It is manifested externally by several dark spots. Further analysis showed that the charged particle plasma velocity over this region was very low, which is characteristic of active zones that have not yet released their stored energy. The whole observation coincides well with the backswitching theory, which explains magnetic switching on the Sun. To make it clearer, it can be explained as follows. So, there are closed and open magnetic field force lines near the Sun and especially over the active regions. The former are magnetic loops that bend into the corona and return inside the star, while the latter emanate from the Sun and connect to the interplanetary magnetic field of the solar system. As the charged particles move along the magnetic field line, only a small amount of plasma can leave the surface of the star. When moving along closed lines, the open ones generate a rapid flow of solar wind. Magnetic switching, on the other hand, occurs in the interaction between regions with open and closed lines of force. As the force lines come together, they join into more stable configurations, like the swing of a punishing whip. This releases energy and creates those very different disturbances going out into space. Such observations can better predict solar wind behavior, solar evolution, and internal processes, space weather, and its impact on satellite missions and weather on Earth. Earlier, back during its first approach to the Sun, Parker was able to capture the dynamics of the solar wind flow using an optical system consisting of 2 telescopes. In this video, compiled from footage captured by the probe, the star itself is out of view on the left. On the right, the central region of the Milky Way is visible. The thin white streaks represent moving interplanetary dust particles, and on the left side of the video you can see a long coronal, relatively dense, slow stream of solar wind. And, of course, the planet Mercury. Parker also discovered near-solar field rings near Venus and created the first visible light images of the surface. The resulting materials show a faint glow on the surface, with continental regions, plains, and plateaus. Such images of the planet, often referred to as Earth's twin, can help learn more about Venus geology and mineral composition. The images show features on the surface of this planet such as Earth's continental regions, Aphrodite, plateaus, mustache, religion and plains, and aliens. Because the highland regions are about 30 degrees Celsius colder than the lower regions, they show up as dark spots. Among the brighter ones are the lowlands. These features can also be seen in previous radar images taken by the Magellan probe. After a successful flyby of Venus, the Parker probe has now approached its 13th mu perihelion. This time, the device is almost 5 million kilometers from the Sun, which is about 8 times less than the minimum distance from Mercury to our star. The probe is headed into a completely different solar environment than it has ever been before. The current 25th solar cycle, which has been running since 1749, is already exceeding all predictions of solar activity. Even though the maximum solar activity has not yet occurred, our star often forms sunspots of enormous size. The star emits numerous solar flares and triggers magnetic storms. So, the peculiarity of this flyby was that it occurred at a time when there was a sunspot the size of the Earth on the surface of the Sun, which threw a giant portion of plasma into space. This is the first time the Parker probe has encountered such an event. Moreover, it is the first apparatus that can observe cardinal ejections at such a small distance from the Sun. In addition, the probe managed to film its cosmic passion. Here we watch the spacecraft pass through the solar corona. It flew past several coronal mass ejections, plasma explosions, and the Sun's magnetic field. It's amazing how close it is to the star. But it's not just the Parker probe that can see. It can also hear. For example, the electric magnetic oscillations caused by flame waves. It captures the interaction between waves and particles, recording information about the frequency and amplitude of the plasma waves, which researchers can then play back as sound waves. What's more, while penetrating through clouds of microscopic dust, the spacecraft's instruments also picked up a sound that resembles the white noise of old TV sets. No, it's not an encrypted signal from the aliens. It's the sound of hundreds of micro-impacts occurring every day as asteroid dust and particles collide with the spacecraft at nearly 700,000 kilometers per hour. The atoms of each particle decay into electrons and protons in the form of a miniature plasma jet, which is what Parker's instrument hears. We bring this series of data to your attention. 6. Amazing, isn't it, that Parker's unique and historic mission revolutionizes our understanding of the Sun, where changing conditions can spread throughout the solar system, impacting Earth and other worlds. The Parker probe is traveling through the Sun's atmosphere, closer to the surface than any spacecraft before it, facing harsh conditions of heat and radiation. All to present humanity with the closest observations in history. The main mission of the spacecraft is set to run until the end of 2025. Its extension is quite possible. Critical is the apparatus' ability to maintain the correct position in space when the flywheels and control system fail. Eventually, the probe will become a fused lump of metal that will fly around the Sun for a very long time and eventually be swallowed up by a homeless ocean of blazing plasma. But hopefully before that happens, we'll have a lot more invaluable information about how our star works. How did our ancestors imagine the world, the cosmos, the universe? Were there in those distant times an intelligible explanation of the origin of the universe, stars, and planets? Or everything ended on flying pyramids and reptiles hiding some secret knowledge? Let's try to figure it out. We have almost all heard of the 3 whales and the turtles that wandered the great ocean, prehistoric peoples of Siberia in whose eyes the universe looked like a starry pasture. Her body is the Earth's firmament, the wool is vegetation itself, and all living things are only fleas of different sizes, big and small and medium. You can choose any shell Slavs, who had a model of the universe consisted of 3 levels of the upper, middle and initial. In the initial went the sun in the evening and the souls of ancestors after death. The middle was surrounded by a boundless sea that could not be swum over. The upper one consisted of 9 crystal spheres. Take, for example, the Inca Empire, which existed in the 11th century. Of course, they also had many oddities, but what is remarkable for us is their system of calendars, which consisted of solar and lunar astronomical calendars. These calendars were incredibly accurate and were a great reference point for the locals. Also the Incas, as well as the Aztecs, at one time paid special attention to the planet Venus. They called it the star that feeds. Why do you think that is? It is also interesting that on the territory of their abandoned buildings, tunnels have been found, on the walls of which are carved or written in the floor images. One of them has a man hovering above the ground. Another floor figurine has a man standing on a ball and holding the moon and sun. Provided these images were correctly understood, the Incas, it turns out, knew about the spherical shape of the Earth. The question arises whence the ancient people knew such information. Further, Sumerians, ancient people living in Mesopotamia, beginning from the 4th 1000 years BC. Their knowledge allowed them to calculate the rotation periods of the stars and planets. They used Helvetius' tragic model of the universe, very similar to the modern one. They divided the entire celestial sphere into a visible part, which they called the face of the sky, and the heart of the sky, a part that was hidden from them, Sumerian. The astronomers separated the rising and setting stars and observed their movement relative to the line where the celestial dome meets the Earth horizon. The highest point of the celestial dome was in the center. We now call it zenith. Sumerians clearly distinguished periods of winter and summer equinoxes and periods of solstice. That is wide knowledge in the field of astronomy and have allowed Sumerians to create the first in history of mankind lunisolar calendar. Found texts and drawings confirm that the Sumerians clearly distinguished 12 constellations along the path that the sun makes during the year. Many historians are sure that even then the Sumerians knew about the existence of all 9 planets of the solar system and another 1/10, about the reality of which scientists argue until now. There are also texts that talk about the planets. The following quote together 6 gods, which have the same position in the sky and which touches the stars of heaven and changes its positions, and passes relative to the stars the same way that the moon passes. So, 6 gods are listed here. Some are convinced that it refers to the Sun, Jupiter, Venus, Mars, Mercury, and Saturn. It is believed that this is the first strict definition of the zodiacal belt known to us in the history of astronomy. But not everyone will agree with this statement, and many believe that they are not talking about the planets in the constellation, and the big object is not the sun at all, but an ordinary star, because the Sumerians had the sun look differently like this. If this is so, then the question arises, what are these small dots around the central star? Could they be stars too? Whether this is actually the case is unknown. Write down what you think about this. We will look at the following example. Examples of the ancient Dogon people of Africa appeared in the lands of West Africa around the 10th century. These non-writing agriculturalists are an ancient people, not distinguished among neighboring tribes. They also walk almost naked and eat, giggling their hyenas. However, historians have been interested in the unusual content of their legends, orally transmitted from generation to generation, for many centuries. And then one day, in 11930 2 French anthropologists, Marcel and German, visited the Dogon territory to describe the mythology of the tribe. And later, in 1950, they published their work. The material explained that in the legends of the Dogon there are not only such concepts as stars, but also planets, and even satellites of the planets. And of the planets of the solar system, Dogon singles out those that are visible to the naked eye: Venus, Mars, and Jupiter. It turns out that they know that Venus has a satellite. Modern science doesn't know that yet. They illustrated their stories with symbols and schemes, sometimes quite complicated, but always very visual. They depicted Jupiter as a large circle, on which they placed 4 small circles of satellites of the planets. We know Europa and Callisto and Animate. Of course, the laws have their own names for the celestial bodies. But most impressive of all is the knowledge that probably indicates the origin and structure of the universe. This information, as some believe, speaks in favor of the Big Bang theory. Is this really the case? Let's read how the formation of the universe was described in ancient law by de Gaulle. Quote, "In the beginning of all things was Amon, who abided on nothing, but was a ball and an egg, and this egg was closed. Apart from him nothing existed. The world within, and we were yet without time and without space. Time and space merged into one in him. But there came a moment when the llama opened his eyes. In doing so, his thought emerged from the spiral that was circling in his womb. outlined the future sprawl of worlds. Interesting, isn't it? Remarkably, this formulation is very close to the one given by Einstein in his theory of relativity. However, after the publication of this information a little later with the tribe met already other ethnographers, who did not find any traces of allegedly secret knowledge. Therefore, they accused the first expedition of lying. Others believe that they considered them unworthy of this knowledge, so they left with nothing. Now it's hard to say which side is the truth. Of course, you can always go to Africa and become part of a tribe, jump over a fire in a boar skin, and drink various gatherings and beverages. But imagine if it wasn't fiction and that by catching up, really somehow knew the facts about the universe. How would you explain it? As you gather your thoughts? Just a reminder that today's theme was chosen by the Patriots. There you'll also find music from the videos and some new episodes. By the way, there are only a few days left until the raffle ends. Great space games in honor of Cosmonautics Day. More details in our group as well. Be sure to share your research on ancient peoples and their views on the universe. It's always interesting. Official history, supported by archaeological evidence, does not go back more than 6 millennia. Many people tend to believe that beyond this period of history as such humanity was not at all, that there was only a primitive existence of disparate groups of people, focused on the extraction of food and problems of survival in the wilderness. But in modern archaeology is very much not solved mysteries, riddles associated with the past of mankind. Archaeologists constantly find ancient artifacts in the most remote corners of the earth and put forward completely different, sometimes fantastic versions of their origin. I propose to set aside skepticism and try to understand by considering several examples. And at the end, we will summarize the results. And we will begin with the find, which is still stumping researchers around the world. We are talking about the July artifact. During excavation work, builders discovered bones and a very strange object resembling an ancient axe. All these artifacts of the past were found within the boundaries of the small Romanian town of Ayoub. The bones were easily identified. They belonged to the ancestor of the modern mastodon elephant. The last mastodons became extinct about 10,000 years ago, either because of climatic factors or because of hunting. But the so-called hatchet turned out to be an extremely curious find, as it is made of aluminum alloy. And the ratio of alloys in the artifacts is such that the value of pure aluminum in the remaining 10% includes 20 different elements. Modern human civilization began to receive aluminum only at the end of the 19th century from the clay of earth rocks with the use of electrolysis. This combination, as found by Axe, it may seem, was not used at all in production. That is, it turns out that these facts indicate that this artifact belongs to some pre-existing highly developed ancient civilization, about which we know nothing. Or maybe it is of extraterrestrial origin. Who knows? Also important evidence of the extremely high age of the piece is the oxide film, formed over time on its surface. The fact is that absolutely every product made of aluminum alloy during contact with atmospheric air reacts and a plaque is formed. The thickness is rarely more than 1/10,000th, but the Asian axe has the thickness of this plaque in a whole millimeter, which roughly corresponds, according to some researchers, a few tens of 1 million years. The presented artifact was studied by representatives of different professions and sciences, but no one has not been able to explain for what purpose this detail was used. But representatives of the aircraft industry put forward a quite logical, in their opinion, the assumption that this detail could be used in the supports of aircraft for soft landing. Aircraft 1 million years ago? No, that sounds like a bit of nonsense. However, there are quite a few such artifact finds, but explaining their origin is sometimes quite difficult. Modern science provides few answers. Few scientists dare to step on the shaky ground of legends, myths, and religion, which very often can be attributed to the fantastic. However, facts are facts, and in addition to human artifacts, there are quite a few more finds and discoveries. For example, figures resembling astronauts found in Ecuador. They are more than 2,000 years old. And here are stone pieces from Nepal, whose age is estimated at 12,000 years old. Here we see images and clear lines carved into the surface of this flat stone. Many researchers have come up with the idea of its extraterrestrial origin. After all, could not ancient people so skillfully process the stone? In addition, the product depicts a creature that is very reminiscent of an alien in its known image. In June 1968, a simply incredible archaeological discovery was made of a fossilized boot print of 3 swans. This class of marine arthropods became extinct several 1 million years ago. Archaeologists have found a fossil that they believe shows a human footprint with a clear boot print. Or does it look that way to us? The museum at the State University of Peru has a stone with a human figure carved into it. Research has shown that it was carved 30,000 years ago. The amazing thing here is that this figure wearing clothes, hat and shoes is holding a telescope and observing a celestial body. How is this 300,000 years ago man holding a telescope? He seems to have some astronomical knowledge as well. But it has long been known to us that the European Galileo Galilei invented the telescope only 300-odd years ago. Who then invented the telescope? 30,000 years ago? Egypt is one of the few countries shrouded in all sorts of hypotheses and myths, from the theory of pyramid construction to finds whose use archaeologists still cannot explain. One such find is the Disk of Self. This unique and one-of-a-kind artifact of the past was discovered during the excavation of a cathedral-scale tomb located in Zachary. This shard of the past is dated to be approximately 5,000 years old. Externally, the artifact is a disk with a complex shape. Its diameter is approximately 70 centimeters. The artifact is made of metaforces. The stone is able to withstand processing even with a significant chin of the processed surface. In this case, the disk has 3 blades, which are bent to the center. In the central part there is a cylindrical hole. When examining it in detail, the researchers could not determine for what purpose it could be used. Over time, some archaeologists have suggested that it is just an outlandish vessel for lighting or a beautiful thing for the interior. But tests in the created mathematical model showed the untenability of this statement. Some historians and engineers voiced a very curious version of the application of the Sabo disk. According to their version, it is a part of the hydraulic propeller of an aircraft. However, this artifact is made of stone. But after all, a stone airplane and do not seem to fly. And, it would seem, it is possible to put a point. But there's one thing. What if this mysterious disk with itself is just an imitation of an older piece, made, for example, of metal? Then all the inconsistencies around this unique shard of the past are explained logically and simply. What if we assume that the Egyptians encountered an older and more highly developed civilization of the past? They perceived the aliens or other beings as messengers from heaven and began to worship them. The representatives of the ancient civilization then left the Egyptians, but they continued to honor and imitate the behavior of their deities in the hope that if they recreated and repeated the rituals exactly, they would return again. And this proverbial disk of self is just a skillful imitation. But even this theory is very hard to believe, because then we would have to admit that there were other highly advanced civilizations in ancient times. But what if it is possible? The age of our planet is estimated at about 4.5 billion years. Modern history tells us that man appeared only some 6,000 years ago. If we take into account the findings mentioned earlier, it is very hard to believe in this rather small figure. So, what conclusion can we draw? Science has not yet been able to convincingly answer a number of crucial questions. For example, how did life on Earth originate? How did humans appear on Earth? Were they created by someone? Or is it evolution? Why are we finding these objects? Are they artifacts indicative of other civilizations, or is it a fantasy of the people of the time? Why were ancient civilizations, such as the Egyptian civilization, born with already very advanced writing, agriculture, complex and orderly social relations? Did it happen under the influence, or maybe with the direct participation of extraterrestrial civilizations or beings with great knowledge? Could it be that humans emerged as a result of a revival of knowledge that had disappeared? If so, what was she like? Where are the material remains of her culture? When and why did she perish? Or maybe mankind developed not independently at all, but under someone else's control, imperceptible and all-encompassing? Or maybe we just want to believe it. The legend of Phaeton was by the sun, Aelios the Wast. His name was Phaeton. One day someone doubted that Phaeton was the son of radiantly Aelios. Then Phaeton was angry and went to the genius of the ACS for proof that he was indeed his father. Aelios dispelled his doubts and, as a token of his trust, promised to fulfill his every request. Then Phaeton began to ask to be allowed to ride across the sky in his father's golden chariot. Although Aelios was against it, he could not refuse because he had given his word. Then Phaeton felt freedom, along with the recklessness of his just a moment, and the earth began to collapse along with its inhabitants. Seeing all this chaos, Zeus of thunder swung menacingly. The hand hurled its glittering lightning bolts. Its flames put out the fire. But that day the Phaeton perished. The chariot shattered into splinters across the sky. And though this story only fictitious legend, but definitely tells us that when that in the far past there was a planet VTO or planet Alberta, which ostensibly was located between Mars and Jupiter, and then has broken up, having formed a belt of asteroids. On the existence of the planet Phaeton still argue contemporaries. But why the controversy? Let's look at some interesting details. And we'll start at the very beginning. For the first time, the idea of the possible existence of a photon arose in the creator of celestial mechanics, Johannes Kepler. He noticed the empty space between Mars and Jupiter and in 1596 suggested that there must be another undiscovered planet there. But at that time people were more focused on blowing tights and wigs, so no one gave Kepler's suggestion due importance. But in 1766, astronomers and Bode discovered that the distance of the then known planets from the Sun obeyed the laws of geometric progression. In general, the law of water is an empirical formula that approximately describes the distances between the planets of the solar system and the Sun. The essence of the formula is a mathematical equation obtained through big data and experience. Interestingly, but according to this principle, in 1781, the planet Uranus was discovered. After that, the search for the missing planet was started. For this purpose, a group of 24 astronomers was formed, which became known in the press as the Celestial Police Squad. Not to be confused with the galactic ones. That's another level. In 1800, astronomer Giuseppe Piazza did discover dwarf planets in the right orbit of the sphere. However, it turned out to be very small and didn't fit the data. And just a year later, Heinrich Albert discovered an asteroid in a close orbit called Paulader. A little later, Juno was discovered, and in 1807 Vesta was found. Later, a whole belt of asteroids was discovered, which is located just where the hypothetical planet should have been. Subsequently, which was named Phaeton in honor of the son of the sun god Helios. But as time went on, research methods improved. So, in 1890, 320 small planets were discovered by visual methods. Gradually, astronomers came to believe that between Mars and Jupiter, in the zone where there should be a planet 5 around the Sun, a whole swarm of small planetary bodies rotates. The discovery of asteroids continues to the present, and to date they have already been discovered about 40,000, and the total number of asteroids with a diameter of more than 1.5 kilometers may exceed 500,000. The vast majority of asteroids are concentrated in the asteroid belt between the orbits of Mars and Jupiter at a distance of 2 to 4.3 astronomical units. Of course, all but the largest of these asteroids are shapeless clumps. But we're curious about something else about their composition. Asteroids are categorized into very dark worms and U-75% type asteroids, similar to basalt and carbonaceous rocks. Then rocky asteroids type 15%, similar to silicate and rocks, and a third metallic asteroids type 10%, presumably composed of iron and nickel alloys, as well as a number of other rare types. Curiously, all of this composition usually has planet-like Earths. It's possible that these are fragments of the very planet that was destroyed. This is us. Not everyone would agree with this. Many are sure that the asteroid belt is not a destroyed planet, but a planet that never managed to form due to the gravitational influence of Jupiter. But, agree, guessing can be long and agonizing. We need more data. And although they are few, but still available, here are some of them. Not long ago, an international group of astronomers was analyzed diamonds found inside the meteorite Alma-Ata Cetus. The team concluded that the celestial body was part of a shattered protoplanet the size of Mercury or Mars that once existed in the solar system. But what are the reasons? The fact that the meteorite with large diamonds, crystals, was part of the asteroid 2008, which fell by Iski, a desert in the Sudan. It belongs to the elite meteorite formed by large Earth, in places, rocks. It is also found to have a high concentration of carbon in the form of graphite and diamonds. It has been calculated that a pressure of more than 20 gigapascal is needed to form diamonds. This indicates that the crystals could not have originated from a collision with the surface of the Earth, but grew in the interior of a large celestial body far beyond. If the protoplanet was no smaller than Mercury, the diamonds would have formed in its center if it was comparable in size to Mars. Then the crystals would have formed at the core mantle boundary. For many, this study was the first reliable evidence for the existence of a planet in the solar system that had already disappeared but burned up. And the news from the photon didn't end there. In 2000, the Yamato meteorite was discovered in the mountains of Antarctica. Its analysis showed that the surface layers are 16 million years old and bear traces of the strongest dynamic stress and melting. Based on the similarity of the gas composition of this meteorite and the modern atmosphere of Mars, it was categorized as one of the 20 known Martian meteorites. Based on this, it was assumed that a catastrophe on Mars could have occurred 16 million years ago. But it was still an open question how the meteorite was ejected outside this planet. This is not clear. However, if we assume that Photon had an atmosphere similar to that of Mars, consisting of carbon dioxide, nitrogen, argon, and oxygen, then the Yamato meteorite could have been a fragment of the exploded planet Phaeton, not Mars. In that case, it is much easier to explain how this block of rock left its planet. The most interesting thing is that if the Yamato meteorite is indeed a fragment of Phaeton, the timing of the supposed disaster on Mars 16 million years ago remains the same. After all, the body should have taken only a few years to reach Mars, flying at a speed of more than 10 kilometers per second. It turns out that the catastrophes on Phaeton, they and Mars could have occurred at almost the same time. The destruction of Phaeton could lead to intense meteorite bombardment of the nearest planet Mars and, as a consequence, the complete cessation of life on its surface. This is true. The history of the origin of the mysterious planet is full of myths and legends. It's not easy to distinguish truth from fiction. After 1 million years, for a long time, there was no scientific evidence that this planet ever existed. Only the assumptions of history and theories, where various scientists, astronomers, and just fantasists put forward their versions. But time has passed, and we, although very slowly, but in bits and pieces, are getting closer to the answers. Time will tell if the planet Phaeton actually existed. Like many of you, I'm curious to learn new things or old things forgotten. So one day I wondered what the Bible says about planets, stars, and such. Why wouldn't it? People have already learned a lot about the laws that govern the heavenly bodies. And most of us would agree that we don't know everything. New discoveries are forcing scientists to rethink how the universe works. The ancient book of the Bible contains statements that helped answer these questions. And back then, it's true, some were burned as heretics. For such heresy. As silly as that sounds. Yet how words about stargazing are remarkably accurate. They were also often ahead of the scientific thought of their time. The Bible was originally written in Hebrew, Aramaic, and Greek. The oldest books of the Bible are considered older than all other religious writings. Its ancient copies continue to find the first 5 books of the Bible were written as early as the 16th and 15th centuries BC. At that time, the Greek philosopher Aristotle's views on the structure of the physical heavens were common among leading scholars. Even today, he is considered one of the most influential scientists. Aristotle developed a model of the universe according to which the center of the universe was the Earth. Around it were more than 50 transparent spheres. In his view, the stars were attached to the outer sphere of the planet and to the spheres closer to the Earth, and everything outside the Earth was eternal and unchanging. These views may seem absurd today, but they nevertheless influenced minds for nearly 2,000 years. Moreover, even today this theory is perfectly acceptable to many. So let's change the name of God's channel to the Evil Dome. But let's compare Aristotle's theory with statements from the Bible. Aristotle believed that the celestial sphere was composed of solid matter. In his opinion, all spheres, including the one on which the stars are held, cannot but contract and expand. However, in the Bible long before this there was a different statement. It has these words: "He is the one who sits above the circle of the earth." Whereas most people believed that the earth was flat or in the form of a dome. Here it explicitly says the circle of the earth, a sphere or ball. In the 20th century, astronomers were surprised to discover that the universe was expanding. As it turned out, galaxies were rapidly moving away from each other. It is now believed that the universe originated from an infinitesimal point and has been expanding ever since. In fact, science has rejected Aristotle's model as outdated. Curiously, the author himself lived almost for 100 years before Aristotle and about 2,000 years before science confirmed what he said. However, unlike Aristotle's convoluted model, the statement of this man, who was apparently far removed from science, is true. But what next? According to Aristotle, the universe was not empty. He taught that the earth and atmosphere consisted of the four elements of earth, water, air, and fire. The rest of the universe is filled with a transparent sphere composed of an eternal substance he called ether. He believed that the heavenly bodies are held together by these invisible spheres. Aristotle's idea was long considered reasonable and logical. The Bible had a different answer, hanging the earth on nothing. Aristotle would probably have considered these words contrary to common sense and would have burned the author as a witch. But by then Job had long since died of old age. Even in the 17th century, more than 3,000 years after Job's day, most scientists believed that the universe was filled with opaque spheres and a kind of liquid. At the end of that century, however, physicist Isaac Newton came up with an entirely different theory. He hypothesized that celestial bodies are attracted to each other through gravity. Newton came closer to realizing that the Earth and other celestial bodies actually hang in empty space. That is, as it might seem, on nothing. Many scientists didn't want to accept Newton's theory of gravity and plotted to burn the poor guy too. But apparently, he was not only a talented physicist, but also an excellent printer. Well, and the history of the universe as recorded in the Bible is very interesting. As, in fact, is the history of never fighting scientists with their original theories. What do you think is credible? The great mathematician of the late Middle Ages, the monk Leonardo, known as Fibonacci, was the lucky one who was able to be the first to notice an interesting sequence of numbers. For example, the sum of two neighboring numbers in the sequence and gives the value of the number following them. For example, 1 plus 1, 2 plus 3, and so on. The Fibonacci sequence begins in such a way that each member of which begins with the third is equal to the sum of the previous two. The ratio of each number to the next tends to 0.618. When increasing, the numbers are ordinal. The ratio of each number to the previous one, on the other hand, tends to 1.618. These ratios are called Fibonacci ratios or number. In mathematics, the expression golden ratio is used. It is such a proportional division of a segment into unequal parts, in which the whole segment so relates to the larger part as the larger part itself relates to the smaller or. In other words, the smaller segment is to the larger as the larger is to the whole. I'm confused. But this does not prevent us to continue. The Fibonacci series could remain only a mathematical mishap if it were not for one circumstance. All researchers from the golden division in the plant and animal world invariably came to this series as an arithmetic expression of the laws of the golden division. Everything that acquired some form, formed, grew, strove to take a place in space and to preserve itself. This aspiration finds realization mainly in two variants of growth upwards and growth of the body not on the surface of the Earth and twisting in a spiral. The galaxy's sun, Earth, the living world and man himself exist in strict accordance with it. Curiously, even people, without realizing it, apply this formula. Designers, photographers, engineers, or scientists. It seems that all flora and fauna, including man, develops according to the laws that are laid down in this numerical and after that dynasty. Since Fibonacci discovered his sequence, even phenomena of nature have been found in which this sequence seems to play an important role. One of them led cab driver or Lester arrangement of the raw, according to which is arranged, for example, the seeds of sunflower inflorescences. The seeds are arranged in two rows, a spiral, one of which goes clockwise, the other counterclockwise. And in general, in the plant and animal world, the principle of economy of biological matter and energy comes into effect. And at the same time, at first sight, we can catch proportions that are pleasant for our eyes. For example, if you look closely at the main stem, you will notice that the lateral branches depart from it through different distances. Dividing them by each other, we get a golden proportion. The length of the petals is also guided by the same principle. It turns out that it is with this arrangement of leaves that the maximum inflow of solar energy to the plant is achieved. Almost all inflorescences and densely packed plant structures, such as pineapples, cacti, cedar, and pine cones, also strictly follow the Fibonacci numbers. What is interesting is that in most flowers, the number of petals corresponds to the numbers in the Fibonacci number sequence. It is noticed that in a lizard, the length of the tail relates to the length of the rest of the body as 60-38. Perfectly the form of dragonfly, which also is created according to laws of golden proportion. The ratio of the length of the tail to the length of the body is equal to the ratio of the total length to the length of the tail. Here the progressive process, the process of growth and development, is clearly seen. These ratios are found also in building of pyramids at Aztecs, in various temples, and in shells. For information, Archimedes, using this ratio, built a spiral, which went down in history as Archimedes' spiral. The most amazing thing is that Archimedes' spiral law is used to form vortices, cyclones, and even galaxies. It is hard to believe that a mathematician 800 years ago discovered the most important mathematical expression of natural phenomena ever discovered. Demonstrating one of nature's grand designs, the pattern of life in endless expansion and contraction. The static law, governing also the dynamic process of a bacterium, multiplies in a progression that can be plotted as a Fibonacci spiral. Its meteorite crashes into the surface of the Earth and forms depressions which correspond with Fibonacci spiral. Pine cones, seahorses, shells of snails and mollusks, waves of ocean, ferns, horns of animals, DNA spiral, clouds, whirlwinds, and storms and galaxies of the open space are twisted in Fibonacci spiral. An eternity of time and light years of space now separate the new bump and the special galaxy. But the structure remains the same. The coefficient is 1.618. Probably the primary law governing active natural phenomena, for otherwise it is a perfectly normal phenomenon to which we are accustomed. And we don't even notice that if everything around us consisted of chaos numbers and appeared by means of random forms, we would all become freaks, just like everything around us. If you think about how coherently the Fibonacci numbers work, you involuntarily come to realize that this is the perfect formula for creating and sustaining animate and inanimate existence. And if it is so, then the question arises that this formula appeared by chance, or it was not only created by someone, but also successfully applied? Write about your thoughts, and perhaps we will be able to unravel the mystery of the universe and the universe. If physics is full of incredible theories and ideas, one of the most interesting is the worm. Exactly. Or a ready-made burrow. Predicted by the general theory of relativity, simply put, the worm, exactly, is a hypothetical object of a non-trivial topology of space-time, which is easiest to visualize as a tunnel connecting different regions of space. The entrances to the tunnel formed by spherical necks, which can be connected by a curve, the so-called inner world. A worm for sure. In general, recently there have been a lot of interesting works that describe what is a kind of bridge through time and space. Everything is possible. This raises several questions. If we discovered it, what would it look like? What phenomena would occur in the vicinity of this tunnel? And the most important question is whether it is possible to travel through and burrow and remain not only with limbs, but also in a sane state. To begin with, let's remember what point worms are. It turns out that they come in two types of possible Maurice Thorez, which require the presence of exotic matter with negative energy density, preventing the worm from collapsing. Thorez and Einstein-Rosen's classic impossible bridges, predicted as early as 1935. A few decades later, physicist John Wheeler mathematically provided evidence that worm necks are accurate, fitting well with the description of what we understand black holes to be. Yes, exactly fit the description, but they are not. The entrances to the worm are precisely the outer parts of Narayan, and their inner parts of the region beyond the event horizon form the worm. Exactly. And what can be said about the exits from it? It's not that simple. According to one paper called The Paradox, and having measured the quantum state of one of the particles of common origin, we can accurately determine the quantum state of another particle without making measurements on it. Yes, we are talking about an unknown force acting much faster than the speed of light on distant particles of common origin. The phenomenon later came to be called quantum entanglement, and the particles were called entangled. But in order for us not to be confused about it ourselves, let's give an illustrative example of how it all works. Imagine you forgot one glove at home. Until you reach into your pocket, you don't know which glove you have, which one is at home. The probability that you have the right or left glove with you is 50%, and we have a superposition of the two possibilities. But as soon as you see that you have the right glove with you, you instantly know that you have the left glove at home. The same thing happens with elementary particles separated by any distance, entangled or prepared in a special way. It's as if the particles retain some kind of connection between them. And if we, having measured the quantum state of one of the particles, we will know exactly the quantum state of the other particle. Today, quantum entanglement has been confirmed by numerous experiments and is even used, for example, in cryptography. Previously, we represented the worm exactly as two black holes connected by an Einstein-Rosen bridge. However, if we take all the Hawking radiation particles from the original black hole A and put them together, creating a black hole in the particle black holes A and B are entangled with each other. We can talk about two entangled black holes connected worm exactly. These black holes can be removed any distance, but their quantum state will interact with each other like cosmic glove. Let's assume that this is possible. Where would there be a path that could connect one region of space-time to another place in the universe, or even another universe altogether? Today, there is speculation that the nearest entry point to the supposed worm thickness may be around Sagittarius, are supermassive black holes under a star, which in turn is located at the center of the Milky Way galaxy. This location is chosen for a reason. Theory shows that this particular location is ideal for creating a ready-made burrow, as it requires extreme gravitational conditions, which is exactly what a massive black hole provides. The study points out that if the worm definitely does exist nearby Sagittarius beneath the star, the nearby stars will depend on the gravity of the stars at its other end. Thus, it is possible to confirm or deny the presence of a space-time tunnel at the center of our galaxy by analyzing gravitational anomalies and deviations in the orbits of stars around the black hole. It is hypothesized that the properties of an actual finished burrow may be very different from how these objects are described in science fiction books and movies. Objects that fall outside the event horizon of moles supposedly accelerate to speeds above the speed of light and end up at the other end of the worm. Right. One of the first to visualize this concept was director Stanley Kubrick in his Space Odyssey in the late 1960s. And a few years ago, the idea was repeated in Christopher Nolan's Interview trailer. True, if in those movies the astronauts were only a little shaken when they got through the worm, exactly in reality all objects that get there will be instantly wiped out into festive ashes due to the instability of the new holes, not to mention the extreme gravitational effects and the highest temperatures, with irreversible acceleration. But let's pretend we own this super ship that can withstand any kind of overload. Then we'd need a negative energy source to keep Krotov alive. I mean, he's open. But we have no idea how to do that. So it's unlikely we'll be able to contemplate the beauty of space-time in a normal state. But perhaps representatives of other planets can do it. Of course, a ready-made burrow seems like a ridiculous fantasy. But that's what they used to say about black holes. And so, in the late 90s, black holes began to be found. They found the kind that a dying star turns into. They found supermassive ones that swallow 1 trillion stars at the centers of galaxies. These objects have enormous gravity, so powerful that they are invisible. It's hard to imagine how and how much space corrects there along with time. It would seem that ready-made holes are something unexplored, incomprehensible, existing only in hypotheses or in equations, the sight of which is frightening. And yet we already have something. The thing is that in the world of particles, space-time is also in the world of vacuum. Myriads of virtual particles are always appearing and disappearing from somewhere. For example, researchers managed to get photons, visible quantum particles, from quantum vacuum, that is from absolute emptiness. And it's not witchcraft, it's reality. So you can put away your pitchforks and flaming torches. This sensational research confirms the quantum mechanical theory that the void is made up of some microparticles, about which science also knows very little. Yes, in fact, quantum entanglement is not a spooky action at a distance. Quite a physical phenomenon in the form of a real bridge in the geometry of space-time, linking distant particles, and does not require exceeding the speed of light by some mysterious carriers of interaction. And this means that in the world of quanta there is both teleportation and microworm sharpened, something that the vast majority simply refuses to believe in. Realizing this, one begins to look at the hypothesis of ready-made holes differently. What are your thoughts on this? Please teleport and put your thoughts into letters. It will be interesting to interpret what you see into your brain. Light is invisible, and invisibility is one of its most understood properties. We only see it when it hits the retina of our eye, and we cannot see light that just passes by without reflecting off of anything. Imagine an empty, dust-free, absolutely sterile room, infinite in all directions, so that before the experiment is complete, the light would not have time to reach the walls and return. Alternatively, the walls of the room would have to be matte, black to completely absorb the light. Now imagine a flashlight turned on in it from the outside. That's great. Except that you won't see the flashlight itself or the light it emits. Paradoxically, light is invisible. We can't see it from the side when it's not reflected from anything. If there were a reflecting object in the ray, or even dust or water droplets to scatter the light, we would be able to see it. But since there is nothing in the ray and we are looking at it from the outside, its light does not reach us. If there were a second light source in the room, we would be able to see the flashlight, but not the light it emits rays of light, however intense. Even the ones we can get with a laser just pass through each other as if there were nothing in their path at all. These reflections are included in the book The Structure of Reality by British physicist and philosopher David Deutscher, one of the originators of the concept of quantum computing. The book is generally illustrative, demonstrating that the era of great philosophical systems is not at all a thing of the past. The authors build a coherent and consistent with scientific knowledge answer to one of the most fundamental philosophical questions: what is the true nature of reality? And today we will try to understand it. To an observer in the beam and walking away from the flashlight with his back to the front, it would reflexively appear even smaller. And when seen only as a point, even fainter. The question arises, is light really capable of spreading in unlimited, increasingly thin rays? The answer is no. At a distance of about 10,000 kilometers from the flashlight, its light would be too faint for the human eye to discern, and the observer would see nothing. So a human would see nothing. But an animal with more sensitive vision? Yes. Take, for example, a frog, whose eyes are several times more sensitive than the human eye. That's enough to make a noticeable difference in an experiment. If the observer was a physicist frog, and she would move away from the electric flashlight, the moment when it would have lost sight of it completely would never have occurred. Instead, the frog would see the flashlight begin to flicker, flashes occurring at unequal intervals that would increase as the frog moved farther away from the flashlight. But the individual flashes would not become less bright. Even at a distance of 100 million kilometers from the flashlight, the frog would see on average only one flash of light per day, but that flash would be no less bright than any other flash observed from any other distance. Unfortunately, we don't know the frog whose tongue it is, which means no scientific discussions can take place with them. Therefore, in real experiments, Lee researchers use then multipliers. These are light detectors, the sensitivity of which exceeds the sensitivity of the frog's eyes and reduces the light by passing it through dark filters. After all, observing light at a distance of 100 million kilometers from the source is slightly problematic. However, neither the principle nor the result changes. Not imaginary darkness is not uniformly dim, but flickering. And the flashes are equally bright no matter how dark a filter we use. This flickering proves that there is a limit to the uniform propagation of light. Each flash is caused by photons impacting the retina. The beam of light becomes weaker, not because the photons themselves become weaker, but because they separate from each other and the empty space between them increases, hence the light becomes weaker. To affect the retina, This property of light appears only in the form of pieces of discrete sizes and is called a quantized individual piece of light. A photon is called a quantum photon. Quantum theory, by the way, got this name precisely because of this property, prescribed to all measurable physical quantities. Yes, everything that surrounds us and seems to be continuous, in fact it is not. There are many different phenomena in quantum physics, and quantum is one of the simplest. But let's get back to our photons. You have, of course, heard many times about Thomas Young's two-force experiment. This experiment belongs to the general class of double-path experiments, in which the original wave is split into two separate waves, which are subsequently merged back into one. Changing the path lengths of the two waves results in a phase shift, creating an interference-complete picture. Young's experience is a classic illustration of the fallacy of theories that view light solely as a stream of particles. If photons exhibited purely corpuscular properties, the screen would show two brightly lit areas behind the slits and a dark area between them. Thanks to Young's experiment, physicists were now obliged to consider the wave properties of light. 1 trillion. But it's not just photons that are inherent to interference. Quantum theory predicts, and experiment confirms, that interference occurs with any particle. So every real neutron must be accompanied by a mass of shadow neutrons. Every electron a mass of shadow electrons, and so on. Consequently, reality is much larger than it appears, and much of it is invisible. And in fact, those objects and events that we can observe with instruments are nothing more than the tip of the iceberg. If your brain still isn't tearing itself apart and you've had time to comprehend the above, here are some more thoughts. David Deutsch believed that shadow particles are separated from each other in the same way that the universe of real particles is separated from them. In other words, they form more than one homogeneous parallel universe. Much more than a real huge number of parallel universes, each of which is similar to the real one in composition and obeys the same laws of physics, but differs from the others by the arrangement of particles. In general, the theory of existence of multi-universes is not very popular among physicists. Perhaps because of disputes among physicists-theorists. Traditionally, the starting point has been quantum theory itself. First, the theory is formulated as precisely as possible, and then try to understand what it tells us about reality. This is the only possible approach to understanding the minute details of quantum phenomena. Regarding the question of whether reality stands from one universe or many. But it won't be a new future, the universe from which the traveler went to the past. It would just be a different version of that universe. So, as you can see, the paradox of the murdered grandfather is easily solvable. So, summarizing, we can state that in interference experiments on the shadow picture there can be such areas that stop being illuminated when new slits appear in the partition. This remains unchanged even if the experiment is conducted with single particles. Hence, by carrying out a chain of inferences, we can assume that this shadow hides other shadows parallel to the universe. So the whole of physical reality contains a huge number of parallel universes. Yeah, that's a little unusual. Even Dr. Spies. And that's just one explanation for the interpretation of this experiment.